Oh, testing 1 2 3, testing 1 2 3. Sorry about the wait, guys. Thank you for your patience. Testing. I think we're ready to come back online finally. Still a little bit frazzled from the shower. Sorry about the late start. Yo, what's up? Welcome back to Vencabot. Intro to Python action. My name is David. Yo, as usual, guys, we're enjoying the music of my friend Aubdat. This is his Bandcamp right here. aubdat.bandcamp.com. His new album out, Aux Vec Teams, is pretty cool. We're listening to his older stuff right now. This stuff is a little bit more rhythmic and more harmonic. It's kind of sick. Go check him out right now, if you please. If you're that kind of thing, it's aubdat, aubdat.bandcamp.com. So, guys, we'll pick up where we left off last time with Python. Let's look at what our code is looking like right now, guys. So, yeah, we have this Pokemon example, right? We've been working on this over the past few streams. At first, we created a version of the game that was fully working. It was a cute little Pokemon battle that I was very proud of for using very, very, very basic programming concepts you see above my head here. I've got all these programming concepts, right? Now, previously, we refused to use classes because they're a bit more complex. We're kind of at the intermediate stage now of basic programming in Python. So now we're utilizing these classes to make our code a little bit simpler. Again, it's more complex to understand, but once you do, it's simpler to read. So that's why I'm moving on to classes now. But previously, our old code had no classes. It was just a big list of straightforward code. And we had it working quite nicely. We broke that all, we destroyed it, we burned it, and started from scratch with classes now. Let's talk about how our new code is working, guys. You guys are probably familiar with how the old code used to work back in the day. Let's look at this new code. So in this new code, our Pokemon attacks, like tackle right here, and our Pokemon themselves are what we call objects, or they're based on classes, right? And the class is kind of like a template for a Pokemon, because all Pokemon have some things in common, right? They all have a monster type, like Bulbasaur. They have an elemental type. In this case, only one. We're kind of having like a really basic example here. In actual Pokemon, they have two types most of the time. Dix says, just like this stream, there was no class. Wow. Yeah, but now there is class. Look at my classy shirt. Now we actually have some classes here. Again, all Pokemon have HP and attack power and defense. So in other words, Pokemon can be essentially built using this Pokemon template, this Pokemon class, right? Whereas before, our Pokemon were just sort of a bunch of loose ideas floating in space. They were like, oh, here's Bulbasaur's attack over here, here's Bulbasaur's defense over here, here's Squirtle's attack over here, right? Like, it was all not very well organized. Right? That's kind of how classes come in. Their whole purpose is to sort of organize your data. Whoa, Dix, all right, you want a fucking button for you, Dix, all right? I'll button all the way to the collar. How about that? Does that make you happy? If I button all the way up here? See if I can do that. Oh, I don't know. My neck might be too fat. Hang on. I give up. I can't do it. But yeah, so these classes, their whole idea is to take all these ideas, like their HP, attack power, and defense, and all that good stuff, and affix it to something, right? We're going to put it all into one big object. So instead of having it just be like, boom, all in the ether, it's floating around, it's all attached to this Pokemon object. And again, previously we learned about, don't button your shirt all the way if you have no tie. You look like a buffoon. I'm not scared of looking like a buffoon, dude. I stream 40 hours a week. I always look like a buffoon. Buffoonery is my gig. My head's shaped like an egg. Is it? Is it? Wow, I'm really self-conscious of that now, Dick. Holy shit. That really turned my whole world upside down. I'm going to turn the face cam off now. Okay, so let's talk about how the code used to look, right? Let's talk about variables again real quick, since we're starting a new stream here. So before we had this thing where we had all of our variables straight down on the left side of the screen, right? No indenting, no nesting. It's all just flat straight down on the below. Let's talk about this. Let's say we used to have like Bulbasaur. We'll have like, Bulbasaur's attack equals 4, right? Bulbasaur's defense equals 8. Bulbasaur's HP equals 20, right? And we would say, Bulbasaur's, move 1 PP equals 10, right? And that for all of his moves. I have that same for all of his moves. But the problem with this is that although we know as the readers of the code that these are all related to Bulbasaur, because you can see its name right there, right? This is Bulbasaur's attack and stuff. But internally, the game doesn't know that these are all related pieces of data, which can be kind of a pain in the ass, right? Let's say we want to have Bulbasaur use an attack or be attacked by somebody. We have to feed in to that attacking code all this data, all of Bulbasaur's stats individually, right? We have to feed in all of his stats individually into this function. And that kind of sucks. It's really hard to read. It's a lot of nonsense. However, if we make a thing called Bulbasaur, like let's say we have, Bulbasaur equals, Pokemon, Bulbasaur, hypothetically speaking, right? This is not really how this works, but in this case, hypothetically speaking, it's kind of like pseudocode there, so what the code might look like. Now we have this Pokemon object, right, that represents Bulbasaur. And that object has what we call attributes. So instead of having a bunch of loose variables, loose data here, we have an object, Bulbasaur, and he might have he might have an attack stat, right? And again, in most programming languages, including Python, the period is like an apostrophe S. It implies ownership. So this would be Bulbasaur's attack, Bulbasaur.attack. He might have, some attack power. He might have some HP or something like that, right? And what's really cool is that now if we want to have like, like some kind of use tackle function, we don't got to feed in all of these various stats, right? We don't got to feed in all of his stuff, right? We can just feed in Bulbasaur himself. We can say use tackle, on Bulbasaur. And now that use tackle function knows all of this data about Bulbasaur already. It just comes packaged with Bulbasaur. So that's why we're moving on to using classes now, because having all this loose variables, it's okay as a beginner programmer, as you're starting off. It helps you understand how variables work and stuff. But as you have more complex operations, you probably want to start packaging your data together into sensible, boxes that make sense. What's up, Carbanoid? How you doing, dude? Let's clear all this pseudocode away. So let's actually look at how our code is working right now. We're talking about a bunch of hypotheticals, right? Let's look at how this code is actually working. Okay, so the first thing we do is we define what tackle is, right? It's a Pokemon move. So we can name this whatever we want. You can name a class whatever you please. We're calling it Pokemon Move Tackle, right? And what we see is we have two methods on tackle. Now, we talked about attributes before. Attributes are like variables that are attached to an object. Here we have the owner attribute. We have the move pp attribute, right? They're like variables you assign to them. We also have methods. Now, methods are functions, right? They're actual operations that are attached to a class. In this case, we have the init function, right? This is a method. It's attached to Pokemon Move Tackle. And we have this useOn function, which is attached to Pokemon Move Tackle, making it a method, right? And what's cool about methods is that they're first, they always get themselves, right? They always get the actual object as its first argument. So in other words, what I'm saying is that if you use, let's say, this move tackle, whatever our tackle is, and we use the use on, let's do it like down here, for instance. Let's do that. Let's just make a new tackle. So what does it take? It takes just itself and the owner, right? So we'll just make a new tackle right here at the bottom. So we'll say like, our tackle equals, Pokemon, let's just say Pokemon Move Tackle, it's our class there. And it needs an owner. The owner's going to be Pokemon 1 in this case. So now we have this new tackle. Right. Now, if we were to use, our tackle.useOn Pokemon 2, right, we're calling its useOn method, right? So we have this a little period here, means ownership. We're saying run the useOn method of our tackle, right? Our tackle.useOn. So our tackle's useOn. Here's the, the argument for it. We'll go up here to useOn, right? As you can see, it actually takes two arguments. It takes itself and a target. But methods always get themselves implicitly. So even though we only have one argument we're feeding it, that's okay, because it gets the first argument from here. Right? So this is actually the second argument, but we're only showing one here because the first one is implicit. So the first thing it gets is our tackle. It gets it right here in the self slot. Right? What's really cool about that is that we can, when we run this method, we can read data about that tackle. So we can see if it has PP or not, right? We can ask ourselves, well, does this tackle have PP? If it does, then keep going. If not, just print off an error message, right? And then we also have our target is a Pokemon, right? So that means that not only do we get that object, we get all of its attributes as well for our information. So we can actually calculate our damage here based on self's owner's attack power. So in this case, our owner is Pokemon 1, right? We fed that in at initialization. So we can actually read our owner's attack power, and we can read the target's defense. Even though we didn't explicitly say, we could just say, we could say, hey, target, give me, target.defense as well. Give me like target defense. Give me owner, type. Right? We could feed it all that data. It's a huge pain in the ass, though. Thankfully, we have these objects that come packaged with a lot of their own data. So we can just feed in target, and we know everything about target, which is kind of cool. So in this case, we have the target's defense. We can use that for calculating damage and stuff. Let's talk more about initialization real quick, though, guys. So in Python, if you have any kind of name, like a name of a function or name of a variable that starts and ends with double underscores, like this, for instance, this init, that means that it's what they call protected, or I like to call it magical, right? That means that it's not really for us as programmers to decide how it works. It actually has a function built into Python itself. In this case, init, when attached to a class, means that this code runs when you first create a new object of that class. Let's talk about that real quick. So we go down here to like Pokemon 1 and Pokemon 2, right? When we define these Pokemon, we feed them a bunch of attributes. This is Cyndaquil. He's a fire type, right? He has 55 HP. He's got 8 attack. He's got 2 defense. We feed in all this data when we make a Pokemon. When we do that, this init function actually runs, right? That's why it's got these double underscores on both sides, because it means that when you make this class, this code runs automatically. It's just it's built into Python, right? When you make a class, this method runs. So you can't name it whatever you want. You have to always name it init for it to work. So every class, well, I shouldn't say every class, but most classes have a specialized init function. What we're doing here is what's called, I think it's called overriding? Is that the term that people use? I'm sorry, I forget the terminology exactly. But the idea is that we're taking a function that already exists, or a method that already exists, and we are replacing it with our own method. What's up, Wade? So every class always has an init function. But what we can do, though, is we can actually write our own code over top of it and replace that init function with our own init function. That's exactly what we're doing here. Oh yeah, I love to code, Wade. I love to code, man. So in this case, we are feeding in a bunch of arguments based on this Pokemon we want to make. Right? We're feeding in a monster type, as it's a method, right? The first thing gets itself. It gets itself first and foremost. That is the object we're making. Then we enter in a monster type, which is like Bulbasaur or Cyndaquil or whatever. An elemental type, which is like fire or water or grass. And then we feed in an HP integer, an attack integer, a defense integer, and then a list of move classes. And as you can see down here, we just feed in one move, which is a Pokemon move tackle. As we learned last time, guys, if you feed in data that's enclosed by these square brackets, it's actually a list. I mean, it's only one object here, it's a list of one object. We actually feed in more if we want to later, and we will. Trust me. Right now, they only have tackle. So the first thing we do is we take all these arguments we got fed. We fed in all this data here, and we assign that data to our Pokemon we're making. So as you can see here, we're taking our self, which we got right here, implicitly. Again, you don't see it down here because it's implicit as a method. Thank you for the follow, what is that? Sralda0220, I'm sorry if I mispronounced that. Welcome aboard, dude. If you have questions, let me know. We're just kind of going through a really basic, real basic, very, very small game dev example and talking about how it works. Thank you for the follow, Resery. Welcome aboard, man. Yeah, we're all talking like we have never programmed before in our lives. I'm trying to go through the very basics of how this very simple code works here. I apologize, that's a little bit remedial for some of you guys. But it's going to be remedial. But yeah, so we're taking these arguments we fed in, such as the monster type. Right here we fed in Cyndaquil, right? And we fed in a Squirtle in the second one. And we are taking that data and we're assigning it to our Pokemon. So we're saying our self.monster type, again, dot means possession, so our selves monster type is whatever monster type we fed in. And our selves elemental type is what we fed in as elemental type. And finally, the same thing for HP, right? Self.HP equals HP, and attack is attack, defense is defense. And we have this move dictionary here. Now this is a little bit more complex. Let's talk about that in a second here. But the same thing happens when we define tackle as well. Even though tackle only has one argument, which is owner, it still has attributes we define, right? So we define that it has a move name, which is tackle. We define that it has a maximum amount of PP, which is 10, and it has a current amount of PP, right? So just like in Pokemon, the PP of a move is its power points. It's how much ammo it has, right? So let's say you can only tackle 10 times, right? That's how much ammo it's got. You got 10 tackles in your clip, and every time you use tackle, your power points are reduced by 1. So you tackle, now you have 9. You tackle, now you only have 8 left. Right? So it starts off at 10, and that's as high as it goes. Its maximum PP is 10, and that's where it starts off. So as you can see here, we're assigning our current PP to what we just assigned as our max. Right there, right? So equals the same thing as the max. And the elemental type of this move is normal, because it's tackle, right? It's just a normal type. Yes, Resery, it actually is. Let me actually get that for you real quick. I can actually punch that into Twitch, I believe. Let's see here. Twitch.tv/Vencabot/chat. Okay, go away, you stupid box. Go away. Sorry, guys. Yeah, I think that, the GitHub is at github.com/Vencabot/intro to Python, I believe. Yeah, thank you, Carbanoid. Yeah, you can go watch the previous episodes of Intro to Python over at youtube.com/Vencabot archive as well. Now, all of our previous examples are available on GitHub at that link I put in the chat there. But this one is not there quite yet, of course. It'll be here. It'll be on the GitHub as of tonight or tomorrow night. But we're changing this code around a little bit today. Yeah, on GitHub we have the previous code, which has a fully working Pokemon battle, but no classes yet. We weren't talking about classes quite yet. And now we're talking about classes, trying to get back to that same point, where we had an actual fully working battle. We're still kind of getting up to that point with classes. Okay, so as a little, one more review, classes have attributes and methods, right? They have variables that are attached to them, and they have functions that are attached to them. And that makes them very powerful for organization, basically. It's for organization, keeping your code tidy, and making things a little bit easier to understand. So let's look at how this code actually works now. So let's first of all talk about this Pokemon code here, right? We talked about how we have these attributes we assign to our Pokemon, including this move dictionary. Now, we talked a little bit about lists last time, which is to say that a list is a bunch of data. In fact, let's make a quick example real quick. Talk about lists a little bit more. Let's make a new file. Okay, we're going to call this another list example. We'll call it lists and dicts, actually. I know my friend Dick Sucker loves dicts. So let's talk about, lists and dicts.py. Okay, so we talked about the basic, you guys know all about integers, like, my integer equals 5. You know about strings, my string equals hello world. Right? Integers are numbers, strings are textual data. But we have some other kind of data types as well, including lists. So we can say, list of numbers equals, 10, 99, 50, 80, 807, whatever, right? It's just a list of data. So what's really cool about lists, though, what's really important about them, is that not only do they group data together in one big one big box, but you can iterate through them. That's what makes them really strong. What's really important about them. Let's talk about that real quick. So we can iterate through lists using the for loop. We can say for, a number, we can call it whatever we want, for a number in list of numbers. We can just say, print off, our current number is, right, and we're going to add in, a number, the number that we're on right now. Okay, now let's just run this code. Can I do that? Okay, cool. So the reason why you want to use lists is if you want to do a certain operation to a bunch of similar data, right? So in this case, we have this list of numbers, which has 4 numbers in it, right? 10, 99, 50, and 807. And then we use this for loop to go through every number in our list and do this thing to it, right? So basically what it's doing is that it's going through every item in the list and assigning it this name. And then we can do this thing to that item in the list. So in this case, we have, for every object in the list, a number. We are printing off a little string for it, right? Let's go look at how that worked. Oops, I'm sorry. So it says here, our current number is 10. Then it says our current number is 99. Then it says our current number is 50. And then finally it says our current number is 807. So as you can see, it went through every item in the list and did this thing to it. It printed off a message about it. And that's very, very powerful, guys. So that's kind of the importance of lists, is not just in grouping things together. That's really more what classes are for. It's really for iterating. It's for doing the same task to a bunch of stuff repeatedly. Right? That's kind of what you want to use a list for. Also, we have, let's talk about indexes real quick. Also, if you want to get data out of a list, you can use an index manually. Let's get rid of this for loop. Let's just leave the for loop there, why not? But let's say, we want to access 807. We can say, print the fourth item in the list is, right? And then we print off our list of numbers at index number 3. Okay, let's talk about how this works. First of all, let's look at it, and then we'll talk about how it works. Okay, so let's run this. So we have to go here and hit F5. Boom. Okay, so the fourth item in the list is 807. That's correct, right? The fourth item in the list is 807. But what we're doing here is we are accessing 807 by its index in the list. And that is to say how deep in the list it is. So what's interesting about this is that in most languages, indexes start at 0. It's kind of confusing, right? So the actual fourth item is at index 3, because this is 0, right? This is slot 0. This is slot 1, 2, and 3, right here. Okay, so at index 3, we have our fourth item, 807. Index 0 would be 10. And that's true of any list. You can access it by putting in the name of your list of numbers, and then some square brackets, and then between the square brackets, put in your index number. Right? So we can do that for any index. Right? We could also say, we could say, print the first item in the list is, right? And we can print that off too. List of numbers 1, right, guys? No, not 1, right? Because 1 is the second slot. We want 0. Indexes start at 0. So the first item is at slot 0. Let's run this code real quick. There you go. The first item on the list is 10. That's true, right? There's 10 right there. Okay. So I'm kind of rushing along, guys. We talked about this last time. If you have any questions, please tell me to stop. But let's talk about dictionaries. They're kind of like lists in a lot of ways, except that instead of having an index that's a number, right? Like an ordered list, has in this slot you have this, and this slot you have that. Dictionaries, their indexes are objects, right? Which is kind of weird, right? Basically, you associate one object with another object. And let's have a look at how that works. So in this case, let's associate a string with an integer, as an example. Let's just say, like, ages, dict, call it a dictionary of ages, equals. And then for lists, you use square brackets, right? But for dictionaries, you use curly brackets. Just one of those things. Let's just say that we're going to associate a string such as, Vencabot with an integer, 31. That's how old I am, right? We're going to do one for, our friend Dick Zucker as well. Dick Zucker. He's 12, right? That's his real life age. Let's say we wanted to have another, another string attached to a number. Let's just say carbanoid. Right? Carbanoid 12. This guy is in real life. I think he's actually, I don't know him all that well. I believe he told me once he's 78. Something like that. Okay, Dix is 13, okay. Thank you, Dix. Trying to keep this accurate here. So what we're doing here is we're making a dictionary, which is to say we're associating one object in 3/4. So let's do it like 0.75. Carmen says, back in my day, we didn't have fancy-ass Python. We had to do it all in an assembly language. You gotta get Wade in here too, right? Let's get Wade in here. So, P1X arcade. I think he's somewhere in like his, he's 50, perhaps somewhere in his 50s, maybe like 52. Anyway, so we have this dictionary, right? And its whole point is to associate a string in this case. He's 34. Okay, I'm sorry. I thought he was 50 something. What does K-Write get? Well, we can add Kenny too here. Let's talk about line breaking, guys. This line's going on really long, right? It's going to have to scroll it. So in Python, what we can do is we can actually use what's called a hanging indent to make it look a little bit tidier. We go right here, and we break the line, and then we indent it 8 spaces. 1, 2, 3, 4. 1, 2, 3, 4. And now we have a nice little indent. We can get all of our data on one screen. Put K-Rec on there as well. Right, Kenny's like, I think Kenny's 17. He's in the prime of his life. Because I feel 52, but he's 34. I got sidetracked there, guys. In any case, what we're doing is we're making this, it's like a map. It's called a map. A dictionary and map are like interchangeable terms because we are mapping one piece of data, which is in this case, a string, to another piece of data, which in this case is a number. right? But it could be anything. It could be numbers to strings. It could be strings to lists. It could be integers to lists or vice versa. It doesn't really matter. You're just mapping one object to another object. And what's cool about that is that you can fetch that data by feeding the dictionary one of your objects. So we could say, Vencabot's, let's just say, carbanoids age is, right? And we're going to access that data using the string. We're going to say age is dict carbanoid 12. Okay. So here we accessed the item in the list by its index, that is, its place in the list, its position in the list, right? But dictionaries they're unordered. They have no order to them. Sure, we enter them in an order, but it doesn't save that order for us. Instead, it saves the associations. It saves, our object to some amount of data. In this case, we're gonna fetch whatever's attached to this string, carbanoid 12. Boom. So it fetches at 78. I'm not gonna keep putting in dict and have to correct yourself. You were literally listening to it. Dicks! Cause I got you on my mind, dude. As always. I'm always thinking about dicks. My friend Dix, that is. Also actual dicks. Okay, let's go over here. I'm sorry. And run this code. Boom. So carbanoid's age is 78, right? We're fetching this data by feeding in this data. Right? So just like a list, when you fetch data from a dictionary, you have to use the name of the dictionary, and then square brackets, and then what's called your key. It's not an index. An index is like a number, and it goes in an order. But a key is, this data here that you have is like the organizational object in your dictionary. So you feed in your key for your dictionary between these two square brackets. What's weird is that when you define a list, you use square brackets, right? And when you fetch that data, you use square brackets. But when you define a dictionary, you use curly brackets. But when you fetch it, you still use square brackets. It's kind of bizarre, but it's not a big deal. Basically, you have to think of it as when you're accessing data from a list or a dictionary, you use square brackets around it. Okay, guys, so kind of a little diversion there. We talked a little bit about lists and dictionaries and how they work. Let's go back to our Pokemon code. All right, so here we have this dictionary we made, right? We made this move dictionary, and it has no data in it right now. It's just an empty dictionary. As you can see here, we have the curly brackets, nothing in between. It starts with nothing. And here we have a list, right? As the last argument in our initialization for our code, for our Pokemon, we feed in a list of moves for it. In this case, they're classes, right? It's right here, the move class list. We feed in both these Pokemon, they only get one item in their list, which is Pokemon Move Tackle. That's the class we defined right up here. Right. So we have this empty dictionary for our Pokemon now, right? Now we say, for Pokemon Move class, in move class list, do this stuff. Now we talked before about how for works, right? For, it's a looping statement that runs this code for every item in a list. Right? Every item in the list gets this name, and then this shit happens to it. And then once we're done, we move on to the next item. In this case, the list only has one item in it, right? So what we're saying is, for every Pokemon move class in the list, right here, we do this shit. We say our new move is Pokemon move class, this thing right here, and we feed it self. What does that mean, guys? Well, let's talk for a minute about initialization, right? So, or I should say instantiation. When you have a class, it has certain attributes about it that belong to that template, right? That belong to that class. However, there are some things that only belong to a certain object of that class. So let's talk real quick about what it means to be a class. Let's do this real quick. I'll get an example open here. I'm sorry, guys, I'm talking real fast. But this is kind of this is the real meat of our lesson today, guys. Wake up, guys! Wake up! This is where things get real. Let's save as instantiation. This is where things get kind of interesting for classes. And I feel like I've not really spoken enough about how this works in the previous episodes. So let's say we have a class, right? That's just gonna be person. It's a person, right? And let's say that let's make an initialization, right? We're gonna initialize this person. It gets self first, and it might have, they'll have a name. Let's just call it, moniker, right? Like David or whatever. They're gonna have, a hair color. That's really important, right? It's very important to know what people's hair color is. And they're gonna have, you know, how big their dick is, right? You gotta know how big their dick is. Those are the 3 most important things about a person: their name, their hair color, and how big their dick is. Period. Don't at me. So we're gonna assign this data, right, to our self real quick. Self.moniker equals, you know, moniker. Self.hair color equals hair color. I'm a little bit here, guys. For the music. And self dot, you know, how big their dick is whatever we fed in here. How big their dick is. Right? So we have this person object, and let's just say that, you know, it can, you know, def, we'll just say, you know, comb hair. As you can tell, it's very important to somebody like me. And it gets itself. And all it does is it prints off, you know, self.moniker, right? It prints off their name, first of all. Excuse me, moniker, I can't spell for shit. Plus, combs, well, I can't spell for shit. Combs their, you know, hair color, hair, right? So if the guy combs his hair, he just gets, you know, a little message here that says they comb their whatever color their hair is. Okay, a very simple class there. Now let's utilize it, right? Let's just say, you know, how about dick sucker equals a new person. So you have a moniker, right? His moniker is going to be dick sucker as well. His hair color is going to be, you know, raven black, like the night. And his dick is going to be, you know, somewhere in the ballpark of, you know, I don't know, 18 of some unit. I don't know what the unit is exactly, but it's 18 of something. Centimeters or inches. They're pretty long, those inches. Okay, so we have this dick sucker person now, right? Now we can have him comb his hair. Let's see if this code works. I might have had a typo in there somewhere. Let's see if it runs. No, see, hair color is not defined. I'm sorry. I have to fix this right here. It's not hair color. It's self.hair color. Is that just mine or one in my mouth? I'm not sure, Dix. I'm not sure. We'll have to figure that out later. This is a simple example, Dix. We're not getting too into detail here about which dick is whose. Here we go. So dick sucker combs their raven black like the night hair. Right. So basically, what we did is we made a new person using our class by feeding it these three things it needed. It needed to have his name and his hair color and how big his dick was. Right. Then we ran this method of that person. Right. But what we're doing here is we're actually running this method on an instance of that class, not the class itself. And let's talk about why that would be. Because person is our class. It's our template, right? That's what all of our persons have in common, is this class. But when we run a init, right, by making a new person, what we're doing is we're not making a new class. Person is our class. We're making a new instance of that class, it's called. We're making a new thing from that mold, right? Person is our mold, it's our class, it's our template, and dick sucker in this case is our thing. He's a thing that we made from that mold. But there are some things you can do with classes before you even instantiate them, right? Let's just say that, you know, person, right? Let's just say person, you know, his alignment is evil. Right? Because all people are evil. This is a fact. Stop objectifying me. I'm sorry, Dix. I'm sorry. Or it's just for the example here for programming. Because we are talking about objects. Right? It's object-oriented programming here. That's why we're using classes today. So we have this person, right? His alignment is evil. So we can now say, you know, print, you know, dick sucker dot moniker plus, you know, this alignment is plus, you know, dick sucker dot alignment. I think that should work. I might be wrong about that, actually. Let's see if this works. Okay, so dick sucker's alignment is evil, right? So even though we never actually assigned a self.alignment here in init, he has an alignment attribute. And that's because the class itself has that attribute. It's a part of the class, right? So what's interesting is that now we can say, you know, we can say print all persons are plus person dot alignment. Women are evil. That's a fact. Whoa, Esmeralda. Whoa. Whoa. Oh, more to Esmeralda. Thank you for the follow earlier, dude. Whoa! Let's run this now. Let's do F5. Okay, so on one case, we say dick sucker's alignment is evil, right? But all persons are evil, right? And that's because in this first line of code, we're talking about Dick's alignment, the instance of the class, right? His alignment is evil. But in this case, we're talking about the actual class itself. It has an alignment attribute. The actual class does. That's because we define it up here. Right? It's not a part. It's not, it's not self.alignment. Right? It's just alignment. That means that it's a part of that class, not a part of this instance. So I want to stress the importance of the fact that self, right? This self object, the self thing we're feeding in here, that is referring to not the class itself, but the thing we make from that class, right? So when we say, self in this case, we're talking about dick sucker. We're not talking about person. We're talking about a person in particular. Likewise, in our Pokemon example, right here, when we say, self.monster type, self.elemental type, we're not talking about Pokemon in general. They're not all Bulbasaur. We're talking about this particular Pokemon we're making right now. So basically, a init is a function that creates an object of that class and then gives it to us. So in this case, we say Pokemon1 equals, Pokemon, dot init, right? That's the same thing, but because init is like a magical name in Python, you don't need to type it in, right? All this data goes to init, right? When you just have the class name and then you're feeding it arguments, that means you're running init. So we're feeding in this data, right? Cyndaquil, and it's elemental type and whatnot. And what we're doing here is we're getting this self object, and we're attaching this data to it, and then we're getting that self object out of it. So we're assigning it, boom, it spits out a Pokemon, we call it Pokemon1. Right? We run this function, it spits out a Pokemon, we call it Pokemon1. And all this data that's attached to self is attached to that Pokemon we just made, but not to the actual class. Not to Pokemon in general, but to this Pokemon in particular. Now, it's kind of complex, I know. It's kind of hard. It took me kind of a long time to understand that. You're probably smarter than me, though. I know you guys are smarter than me, but it took me a while to really understand the difference between a class and an instance of that class, right? The idea of it being a template, which is the class, and then what you make from that mold, which is the instance. But the reason I bring that up is because we're doing something kind of advanced here, right? Now, normally at a low level of programming, you pretty much only use the class for one thing, which is to instance it, right? Like here. In this case, we're basically using the Pokemon class to instance Pokemon. We're using it as like a Pokemon factory. It spits them out and we use them. But we're doing something kind of advanced here. We're actually feeding in, as a part of our list here, the class itself for tackle. We're not feeding in an instance of tackle. We're not feeding it a certain tackle in particular. We're feeding it the idea of tackle. We're feeding it the mold of tackle, right? The template for tackle. We're feeding that in as an argument. So how are we using this class in our initialization? Well, here's what we're doing, guys. We're taking every class in this list and we are instantiating it. So we're feeding it a list of templates and we're manufacturing moves, instances of each of those templates, right? So here's what we're doing. We have this new move, right? We have a new move and we're making it using this class we got. Right? As you can see here, we have this variable here called Pokemon Move class. It's referring to every item in this list, right? That we're iterating through, that we're kind of going step by step through. So for every list, every class in this list, we call it Pokemon Move class, and then we do some shit to it. In this case, we're instantiating it, whatever it is. Now we know that Pokemon moves take one argument, right? What does tackle take? It takes an owner. It takes whoever owns that move, right? So that would be Bulbasaur, it would be Cyndaquil, whoever owns that tackle in particular. So we're feeding its argument as ourself, or the Pokemon we're making, right? So we're in init right now. We're making a Pokemon. And we're saying, for every class of move you give me, I'm going to make a move of that class and make myself the owner of it. So we feed in a tackle. And now we're getting, a tackle for Bulbasaur, right? We're making a tackle from that mold. And we're making our Pokemon the owner of that move. So now it's saying, this is Bulbasaur's tackle. And then we're adding this move we just made to our move dictionary. Right, we have this empty dictionary here, right? We're adding stuff to it. Now let's go back to our example for lists and dictionaries. Right. So here in our example for lists and dictionaries, we've got, we made a list, right? And then we access the stuff in there by index, right? We made a dictionary, right? And we access the data from it by key. But you can also add stuff to a dictionary like this. You can also say, like, ages dict, a brand new key, like Lord Johnny, 444, right? And then you can assign to that new key as well. So we're saying Lord Johnny, his age is going to be, I think Lord Johnny in real life, I think he's somewhere in his early 600s, I think, like 612, I think that's how old he is. Right, so we have this a brand new key, and we're defining it, we're giving it a new value. Right? So even though we didn't define it right here, we can add stuff to a dictionary at any time. We can easily add to it, right? And then we can print off, print, Lord Johnny 444's age is, you can print off, age is dict. I misspelled it. With dict again, that's weird. Why am I doing that? Age is dict, Lord Johnny 444, that's our key, right? How you doing, Lord Johnny? Welcome aboard, homeboy. Let's run this code. Yeah, so Lord Johnny's age is 612, right? So even though we didn't define him when we defined the dictionary, we can add to it at will, just by, adding a new key like this, and then assigning to it like so. What's your question, Carbanoid? Yeah, always good timing, Lord Johnny. It's always a good time here on Vencabot. I try very hard anyway. Okay. So before we address Carbanoid's question, can you use the value to get the key back, or is it only one way? Well, it's only one way, but there are workarounds. Let's talk about the workarounds, guys. So what Carbanoid's asking is, can I feed in the age and get the name back? Right? Can I feed in 31 and get Vencabot? Well, here's why you can't, Carbanoid. Because the key itself is unique. You can only have one object per dictionary that uses the same key. So let's say I want to feed in, let's say that Vencabot's changing his age, right? Let's just say, let's go here, for instance, let's just say, Vencabot is, 200 and, he's 2018, right? He's 2018. The problem with this is that if I want to access 31, we can't anymore. Because we access it by doing this, right? We access 31 by putting in ages dict, Vencabot. But now we have this other key, Vencabot, right? So this key overwrites that key. So the keys have to all be unique. They have to all be unique, right? That way you don't have anything overwriting each other. However, the what's called the value, this is the key, and this is the value. The value can be whatever. It doesn't have to be unique, right? It can be, we could all be the same age, really. It doesn't really matter, right? As long as the key is unique, it doesn't really matter. But the problem with then using the value to get the key back is that you have no way to get, you can't get one of these guys in particular, right? Because they're all the same value. However, I mean, what you can do is you can hack it, kind of, by doing something like this, right? I think what you can do is you can do, I think it's called pairs. I may be wrong about that. Let's try this. Print ages dict dot pairs. Am I wrong about that? Let's run this. No, it doesn't have pairs. Let me go look at what the actual attribute's called. Let's go to our documentation here. I'm going to do it for you guys real quick. And that's at docs.python.org. Then you go to a library reference. And you can read all about individual data types and all the cool things they can do, different methods you can use in the libraries you can import. It's kind of cool. There we go. So Ziller's got my back here. For KV in H, items, thank you, not pairs. Yeah, that'd be items. Thank you. Yeah, let's go through that example you just did there. So items, that returns a list of pairs, right? Let's see here. Items, for a new view of the key value pairs. Okay, yeah, so that's exactly what Ziller's talking about. Let's go punch that in. Thank you, Ziller. Welcome aboard, homeboy. Okay. So we can say, yeah, we got this example here. Let's put in some more ages here. We'll do like 32. We'll have this guy be like 41. Have you be like 108. Have you be like 26. needs 4. And Vencabot, we can get rid of Vencabot there. We already got Vencabot. How you doing, Ziller? Okay, a little bit, I'm again here a little bit. It sounds kind of resonant. A little bit grindy. Okay, so let's go down here. No, I'm doing pretty well, Ziller. Kick-ass time. Going through some Python basics. So yeah, so we can do, you know, use the items, right? For KV and age items. If V equals 32, exactly. Yeah, I feel like we haven't talked about tuples yet on the stream. But, yeah, I think that Ziller's example is the best way to do it. We'll talk more about tuples later. But, yeah. What we can do is we can assign... If we're getting a tuple back, like, let's just print off, you know, ages dict.items, right? Wait, does that actually print off? I'm not sure if that works because it's not really a list. It's getting a little bit kind of advanced where we are. Getting a little bit advanced where we are in our lesson. But, let's see here. We can print off all these tuples, right? So when you use the items function on the items method on a dictionary, it prints off a pair for the key and the value, right? So we have this, it's a list, right? It's a list of key value pairs. We have Vencabot 32, Dix 41, Carbanoid 108, Wade's at 26, Kenny's 4. See that? And what you can do is you can then test that pair, like Ziller was doing. Let's do that. So we can say, you know, for, you know, our key and our value in this list of tuples, right? That's exactly what Ziller was saying. Right, so we have all these tuples. Then we can say, you know, if our value is, you know, whatever we're searching for, like, let's just say, you know, 4, then we can access the key. Right? That's kind of a hack. But yeah, so basically what I'm trying to say, Carbanoid, is that you really can't. You really can't access the data. You can't access the key by the value. You wouldn't want to 9 out of 10 times, right? You really wouldn't want to. But if you had to, you definitely could, like as Ziller pointed out. This code will work. That's one way you can do it. So we got Kenny, right? We fed in 4 and we got Kenny out of it. But basically, because the key is unique, yeah, because the key is unique and the value is not unique, you pretty much don't want to get the value. Well, you can do though. Let's talk about something else. Let's talk about like exactly, Ziller, exactly. Like a good example would be, let's say that you want to get everybody who's 32, right? What you could say is you know, if our value is 32, then you can get everybody who's 32 years old, right? Yeah, see? So it's kind of a good use of that. I'm sorry, I was kind of mistaken there when I just told my friend Carbanoid that you would never want to access the key by the value. You might want to access the key by the value, sure. And that is how you would do it. So you can get everybody here whose age is 32. You can get them all if they're, you know, let's say you want to get everybody whose hair color is black. You can access it that way as well. But yeah. So this items, it returns a tuple. We haven't really talked about tuples yet, but basically they're kind of like grouped data, but not in the same way that a list is. A list is for iterating through, right? A list is like you want to go through this, then this, then this, then this. Where a tuple is more like all this data is associated. It's kind of like a class, really, or an instance, but it's much more simple than that. Let's go over that real quick, in fact. We just say, you know, my tuple equals, you know, Dick Zucker, Raven Black, and 18, right? I don't know how you knew my age. Dude, I'm really smart, Lord Johnny. I know when you are sleeping. I know when you're awake. Yeah, so in this case, we have this tuple, right? And this tuple represents Dick Zucker, right? We had this person class before, right? It was kind of a simple class. Instead of having a class, we just have it be a tuple in this case. So this tuple represents Dick Zucker. It has a name, it has a hair color, and it has a length in inches of his dick, which is 18, right? So you can access that data kind of like a list. So let's do that real quick. Let's actually get rid of all this code. Well, let's save this code. Who cares? We can say, you know, print off my tuple, you know, the second slot, which would be index number 1. Lip swirly. How you doing, dude? So we got the Raven Black, right? That's index number 1, or the second slot of this tuple. It's kind of like a list, right? But the difference is that you don't iterate through a tuple, Right? You don't actually go through like a for loop over a tuple, because the purpose of it is not a list of similar things. It's a bunch of related data, and you can enclose it inside parentheses. That's what makes a tuple. Now, what's cool about tuples is you can unpack them. Right? In this case, we're unpacking a tuple right here. So because every item in this list, right, this method here returns a list. This method gives me a list back, essentially. It's actually called a dictionary view. It's not really a list, but it's basically a list. It gives us back a list here, and that list is of tuples that each have 2 items. So because it's giving us back a tuple, we can actually get 2 pieces of data out of it. Right? Our key and our value. Right? That's kind of cool. That's kind of how tuples are really used. Tuples are used when you want to feed in or get out more than one piece of related data. So in this case, this items method of our dictionary, right, has this associated function called items. That makes it a method. This items method gives us back a list of tuples, and those tuples are the key and the value, the key and the value, the key and the value. And so because it's a tuple, we can actually just use this right here. We can say, I want our key and our value, or we can call it, first, tuple slot, second tuple slot. Right? I just want to point out that these variable names here, we can define these. It doesn't really matter. We can call them whatever the hell we want. Right? So we just have to say, if, first, if second tuple slot, this is our value, is 32, then print off our first tuple slot. Right? Or we could call this, we call the first slot, blue baby bird. We can call this one, red ribbon, Rasta. It doesn't really matter. It does not really matter at all. We just call this one, red ribbon. As long as we're consistent with our naming of our variables, we can call them whatever we please. Right? Of course, you probably want to use one that's easier to read, right? No one knows what this means now. No one knows what this means anymore. It's just a bunch of gibberish. But it's important to note for total beginners that you can name variables whatever you please, as long as you use that same name in your code later on. The name does not matter at all. You want to use a name that makes sense to you so you know what it is later. If you're not going to use the iterated name, you can use underscore. I'm not sure I understand what you mean by that, Ziller. Use the iterated name, you can use underscore. But yeah, in any case, that's basically how lists work, how tuples work, how dictionaries work. Let's go back to our Pokemon code. Kind of sidetracked there, which is cool. I like getting sidetracked. Because we're learning. Okay, so let's talk about, this is kind of a complex 3 lines of code. We've been spending all this time trying to build up to understanding how these 3 lines of code work. Right? So for every class we supply in this list, right, the list of classes, not instances, but classes, we're making a new instance of that class. So for every class we supply, we make an instance of it called new move. And we supply ourself as the owner in this case, the only argument. And then in our dictionary, the move dictionary, we're adding a new key. What is that key? That's our new move dot move name. Right? So our key is a string. It's the name of our move. So what the hell is new move dot? Where does that come from? Well, it comes from this class, Pokemon move class. Right? So Pokemon move class refers to whatever step of the list we're on. We only have one item in this list, so it's Pokemon move tackle in this case. Right? So you could replace this essentially. Right? Think of this as being, Pokemon move tackle, right? But we're giving it the name Pokemon move class because we're iterating through this list, right? So it's Pokemon move class, and we're instantiating it, right, with self as our owner. When we instantiate this class, what do we get out of it? Well, we get this thing, this move name, right? We get this move name attribute out of tackle. So what we're saying is, in our move dictionary, we are making a new key called tackle, and we're adding in this instance, right? We're adding this instance of Pokemon move tackle, right, with ourself as the owner. That's what we're doing basically. But we're doing that for every move class we feed in because it's a for loop, right? For everything in this list, we're doing that. So right now we only have the one move, but in the future we're gonna have other moves. So it's kind of cool, right? It's very versatile. So we're feeding in the new move dot move name, and then it's getting out this new move we made. So let's see how we use that. right here in our code. So let's try to get rid of this here. This is the code we just added for today. So now we're saying we made a Pokemon 1 using this class, and we made Pokemon 2 using this class. Now we're saying Pokemon 1's move dictionary, right? He has a move dictionary right here. We created that, right? His move dictionary, access from the key tackle. Right, we're getting the tackle out of it now. Use on Pokemon 2. So this line of code is kind of complex. Basically, we're saying, access, right? Access the move instance that's saved at movedict's key tackle, and use its method. Let's actually break a line here. And use its method use on with the argument, Pokemon 2. Right. Kind of a dark font there. I probably can't even read that, to be honest. So you can use for loop to check for an item, and instead of assigning the iterator to a variable, you can just use underscore. Is that like some kind of magic object in Python? Never heard of that before. If you can master class and inheritance and take advantage of OOP, you'll be in a really good spot. Yeah, this is really a very powerful tool. Again, in our previous episodes of Ziller, we've really been avoiding this. We've been trying to learn the basics of how a program flows from top to bottom, right? But now we're getting into class. It's a little bit more complicated, but it's really worth it to learn, trust me. Wait, I've been coding for 20 years now. I started when I was 13. So not quite 20 years, because I'm 31, so about 18 years. Hey, thank you, Ziller. Yeah, this underscore thing. I'm not sure exactly how you mean to use that. I don't think I've heard of this before. Okay, so basically, yeah, it's kind of a complex line of code, right? But what we're trying to say here is we're using the Pokemon's move dictionary, and we're accessing the tackle out of it, right? Whatever is at this tackle key in the dictionary, and then we're using that object, which is it's an actual instance of tackle. We're using its use on method on Pokemon 2. So here's our tackle, right? It has this use on method. It takes a target, right? So we made a tackle out of this class, and we're using its use on method on the second Pokemon. Okay, import random characters. Okay, gotcha. Password result equals, okay. For blank in range. Password result plus random choice characters. Oh, I see. Okay, I understand. Yeah, I understand. You're just throwing away that variable. You don't need it. Okay, I gotcha. No, well, you can figure it out, dude. So if you go back and watch our earlier episodes on YouTube of this Intro to Python, you can get started at a simpler point. We're kind of at a point where we're a little bit deep in now. We're kind of at the intermediate level, but the previous streams are much more beginner-centric. They're much basic. They're like, using Notepad. Your first time ever programming ever is covered in those earlier examples. Yeah, it's kind of complex, guys. Again, we're kind of, if you missed the previous episodes, you're kind of coming in the middle. Previously, we talked more about how to use variables, how to use functions, what it means to have logic in your code, and more fundamental type stuff. Today, we're talking about something a little bit more complex, which is object-oriented programming. Yeah, exactly, Carbon. Yeah, it was pretty easy at first. So what's making it so complex is that we are connecting objects together. In fact, let me get a notepad open here so we can kind of collect our thoughts together. All right, let's collect our thoughts together. Okay, guys. So, in previous episodes of Intro to Python, we discussed much. Let me get some word wrapping here. We discussed the very basics of what it means to write a computer program. Right? We discussed saving data to variables and using those variables in interesting ways, such as adding them together, putting them on the screen, etc. We also talked about how programs flow. In most cases, they flow from top to bottom, but you can put forks in that flow based on logic. You can have a program do one thing if a value is below 12, or do a different thing if that value is 12 or above. Right? And finally, we talked about how to make your code loop. By using while and for statements, you can actually have your code flow downward and then back up again, and then down again, and then back up again, and so on, right? So you can actually have code that goes down and then jumps back to the top, and then goes down and jumps back to the top, right? So most of the time code flows straight down. But other times you can make it branch off, you can make it go back to the top, and things like that. But what's complicated about object-oriented programming, or OOP, is that you sort of break the flow of your code. Instead of always going from top to bottom, you have to understand how what you're doing is moving all around your code, right? So let's look at that. What I mean by that. What I mean by that is that instead of flowing from top to, we're not exactly like, defining tackle here, and we're not using this code right away, and we're not defining this right here, and things like that. Instead, we are defining all this shit at the top. We define all these classes at the top of our code, right? And then down here, we use what we defined up here, right? So it's kind of weird. That for loop with our move class threw me for a loop, no pun intended. Yeah, well, it's kind of my fault because I wanted to make something kind of cute. So basically, let me go in here and write this down for you guys real quick. As you guys become stronger programmers, you're going to find ways to save lines of code. You're going to find ways to group ideas together in ways that that are more complex, but serve to express your ideas better, right? Because you're going to have more complex ideas, right? Your ideas are pretty complex. And as you become more fluent in any language, that's Python or French or Japanese or C++ or whatever, as you become more fluent, you can learn to express more complex ideas, right? And a lot of the fun of writing poetry or writing programming is that as you become stronger with the language, you can express yourself in more creative ways, right? And I feel like it's my fault because I've kind of used my skill as a programmer to make this little loop here that's kind of cute how it works, right? But it's not exactly easy to understand. It's kind of complex. So what if I could think of a way to make this simpler for you guys that are beginners? Because what we're doing here is kind of like this line of code right here, for instance, right? Look how many fucking periods there are in there, right? We're saying Pokemon 1's move dictionary from the key tackle, is use on this other Pokemon, right? It's a little bit involved, but that's really what we're getting into as object-oriented programmers, right? We're starting to get lots of attributes and lots of data pulling at each other. We're pulling data out of this and putting data over here and taking this value of that attribute and putting it there. It's a little bit more complex. So let's talk about this 3 lines. Let's focus on these 3 lines for a while, guys, because I really want to drive home how this works. When I wrote them last time, I knew it was kind of complex. It's a little bit bizarre. Let's discuss these 3 lines. I wish I could even... Here's what I can do. I can actually shrink this like this so we can see the lines we're looking at, right? There we go. All right, so down here, here's the lines we're looking at, right? These. Can I highlight these? And go back to Notepad. Yes, okay. So let's break some... Go down here and get a blank screen here. Right. So when we create... let's just say when we instantiate or, create a new object from our template, our Pokemon, the last piece of data that we feed in as an argument is a list of move classes. So let's say, Pokemon move classes. Right? That's this right here. The last piece of data is a list of classes. In our example, we only have one class. In fact, it'd be easier to understand if we use more than one class. Let's do that real quick. Right? Actually, I'm not going to say this. Let's make a new class real quick of a Pokemon move. Let's just make a real simple Pokemon move. Let's call it, class Pokemon move, comb hair. Right? Just combs hair. That's all it does. It's not a real Pokemon move. We're just making one real quick. Then we're going to say, we're going to define a new init, which means we can make this object. And just like our Pokemon move tackle, it has all these same attributes. It's going to have an owner. It's going to have a move name, which is going to be comb hair. It's going to have a max PP, which is going to only be one. We can only use it once, right? Just in real life, only comb hair once. Then you die. It's going to have a current PP, which is going to start off, just like our Pokemon move tackle, to start off with our whatever the max is. Starts off at maximum. What's up, Corey? I'm going to read that message in a second here, dude. It's going to have an elemental type, but it's going to also be normal. Right, so it's a normal-ass move. It's comb your hair. Real basic. And then just like Pokemon move tackle, it has a use on. It has a use on method, right? Let's do that. So it's going to give it a use on. It's going to have the same argument. It's going to be just a target. And unlike this is a very complex move, right? Tackle's kind of complex. We're just not simply, going to say, just print off, self.owner.monster type plus combs its hair. That's all that it does. Very, very simple attack. All it does is comb its hair. It's not really an attack at all. But now we have more than one kind of move we can use. Let's actually feed that in here to our Pokemon 1. So let's actually break this line. I'm sorry. Thank you for the follow, Fabirex. Fabirex. Yeah, thank you, Corio. I'm going to read that message in a second here, dude. I apologize about the wait. We're kind of getting in deep right now. I'm going to feed in this second item in this list now. So we have this list, right? It's going to have Pokemon move tackle as one. It's going to have Pokemon move comb hair as its second item in its list. Right, and we'll do that same thing for this Pokemon 2. This is going to be a Cyndaquil. It's going to have a tackle. It's going to have a Pokemon move comb hair as well. Okay. So now we have this a list of move types, move classes. It has more than one item in the list now. Let me read a Corio's message here. It says, hello, could you please explain a single multi-thread? I was writing a program that makes tons of calculations, but couldn't do a calcs per second function because it wasn't able to start out of the already running function. Zero says you need to pool the functions. It wasn't able to start out of the already running function. I'm not sure I understand your issue, Corio. What's up, hello, CodeMoo? Can you please help me here? Nickel count is 100, dime count is 200, total coins equals 0. Your solution goes here. Print total coins. Yeah, it sounds like your homework, dude, but we can talk about it for sure. So, CodeMoo, if you have 100 nickels, total coins, you have to add them together, right? Write a statement that assigns total coins with the sum of nickel count and dime count. Simple output for the given program, 300. Yeah, hello CodeMoo. What you want to do is you want to assign total coins. They want to say total coins equals, and then you're going to combine your two variables, right? Do you know how to use variables, CodeMoo? Let's talk about that real quick. Let's give me a CodeMoo example here. But Corio says, running function X can't run function Y out of function X. Is that an error you're getting, Corio? An error message? Thank you for the sub, Templar. I appreciate that. Yeah, let's talk about CodeMoo. I'm going to actually make a new file here for CodeMoo. A lot of you guys might be beginners. We talked about this in our first ever streams about how variables work. Let's review how variables work real quick for CodeMoo. So CodeMoo, if you have like some value equals 200, and then you have another value equals 500, and you want to say total value equals, something goes here, right? Something goes there, right? What you want to do is you want to use the variable names, right, and combine them. Yeah, I'm sorry I'm having internet problems, guys. I see that now on my side. That's why you guys lost connection. Welcome back, guys. Hopefully it's not an issue ongoing throughout the night. Welcome back, CodeMoo. Yeah, so basically, you have these two variables, right? And you can use variables anywhere you want. So we can say, let's just say, for instance, we can say, like multiplied value equals, some value multiplied by another value, right? So basically, when you assign a variable, I'm sorry, I don't want to save this. When you assign a variable, using this assignment operator, you can use that name later as a part of another assignment. So we defined some value, and we defined another value, and now we can use those to combine them or multiply them or subtract them. See what I mean? The answer is 9. I don't think it's 9. Let me reread your message here. No, but it's what I accept it being, but the function y just doesn't run. Well, it doesn't run. Let me reread your message here, Corio. I think that threads might not be your issue. It sounds like you have some kind of other weird issue. I was writing a program that makes a ton of calculations, but couldn't do a calcs per second function because it wasn't able to start out the already running function. Yeah, I feel like maybe Corio might be getting a little bit ahead of yourself. That sounds like you definitely would need threads for that. You definitely need threads for that. But so basically, a thread is like one program, right? It's like it runs from top to bottom like any other code, like any other program would, right? But if you have multiple threads, you can have multiple functions running at the same time. So if you have only one thread, you're trying to figure out how many calculations are going per second, you really have no way of knowing how many calculations are running because you're already running those calculations. Right? You have to, if you're running a calculation, you can't also figure out how fast it's running per second or how many are running in a second because it's too busy doing that calculation, right? So you definitely would need more than one thread. It's a little bit more advanced than what we can do right now, Corey. That's a really complex area of study, understanding how threads work. $300 testing 9 nickels and 0 dimes outputs differs. See your highlights below. Your output 300 expected to output 9. Testing 100 nickels and 200 dimes. Your output is 300. Yeah, because it's the total number of coins, right? Testing 9 nickels and 0 dimes output differs. Yeah, CodeMoo. CodeMoo, is English your first language? Like running infinite for a loop and async counting CPs. Yeah, so basically if you have a loop going that's just going and going forever, and you want to run some other data that's keeping track of that loop, you have to do it from the outside. You need to have more than one thread. Yeah, but inside the calculation, it increments the i's that reset every second and displays it before resetting. Then it should only need one thread, I think, Corio. I wish I had the time to sit down with you and look at your code and see what exactly your error is. I feel like your error is, the problem is not what you think it is. I think it's not necessarily related to threading. If you're trying to run some kind of code and you're some kind of function and it's not running at all, and you're not getting an error message to figure out why it's not running, something is definitely going to miss. Yeah, CodeMoo, I feel like if your understanding of English were stronger, you would be able to understand how that problem works. I feel like based on what you're telling me, CodeMoo, you're not understanding the actual problem because of your limitations with your understanding of English. I apologize, dude. I feel like I can't help you that much, CodeMoo, because the issue is spelled out very plainly for you in that example, and you can't communicate to me what the problem even is. It's going to be very difficult for you, I'm afraid, CodeMoo. Good luck, my friend. Good luck. Yeah, but inside the calculation, no, you can't, because it would sleep the calculations. I think I misunderstand you, Corey. Let me do a quick example here. If we have, define, a function. Let's call it function A. All right, let me just say, print function A is running. Let me define function B, and it runs function A. Well, let's say, function A, right? And we're going to say print function A ran, and function B is running. I'll actually get this, be a little more tidy here. Right. Let's just save this as, nested functions. Right. And if we run this with F5, I'm sorry, that's the wrong key. Oh, actually, we have to run it. I'm sorry. You have to actually run function B. Okay, so we have function A is running, and function A ran, and function B is running, right? If function A is not running here, you have a major problem. And from what you're describing to me, that's your problem you're having, right? Like, you're trying to run a function from another function, and you're not getting an error message, but from what you can tell, it's not running at all. Is that correct, Corio? And if that's the case, something is majorly wrong with your code. I feel like it's not threading related. Yeah, Faust. In this case, it sounds like my friend CodeMoo, his textbook is in English. That's the problem. Right? It's not that the language itself has any kind of bias toward English, like Python. It's that his textbook, the actual problem, is written in English, and I feel like he doesn't understand it. Like, make function A looping and function B running in a loop too, but not in the same function. We can do that, Corio, but I don't totally understand what you mean by that. Let's get started here. Run it in a loop, but not in the same function. Make a function A looping and function B running in a loop. Make function A looping. Do you mean like put a while loop in function A? Like while true, print function A is looping? Is that what you mean by putting a function A in a loop? And then make function B running in a loop too, but not in the same function. Make function B running in a loop, like down here. Like while true. Like that. That's my problem. I have two loops that should work in the same time, because function A isn't time delayed. The function B is, thank you. I'm sorry, I misunderstood you, dude. Yeah, that's very much, you definitely need threads for that, my man. You definitely need threads for that, because if you use the sleep function, like you're talking about time.sleep, right? Right, you're talking about, import time. You're talking about time.sleep. When time.sleep runs, your entire program freezes. So if we had function B being like, let's just say, function A while true, time.sleep once per second, right? I think that's what your problem is. Let's see if we can get this to work right. If I understand you correctly. Okay. So we don't even need this loop. Yeah, exactly, Ziller. Yeah, he doesn't know what threads are yet. We can talk about that, but I'm not sure I really have. We're really kind of trying to focus on the fundamentals of basic programming, and threads are a little bit advanced, but I might be able to have time to try something like that for you real quick. So yeah, so let's see here. F5 to make it run, right? Okay, just doing it once per second, right? But I think what your problem is, I'm sorry, let me put this over here. I think what our friend Corio is saying is that he wants this to print off, right? He wants to get deeper into function B, but he can't because function A is looping forever, right? Is that what your problem is? That's why this part never runs. Yeah, CodeMoo. Testing, your output's correct. That your problem, CodeMoo, is that you're still doing I'm sorry. Let me type in the chat. Your example problem is actually two different problems. Problem 1, 100 nickels and 200 dimes. Your answer is correct, 300. Problem 2, 9 nickels and 0 dimes. You have not tried that problem yet. I feel like you don't understand this because of your weakness with English. That chatception, yeah. Yeah, CodeMoo, your answer is correct. 300 is correct for the first problem. But there's two problems there. There's 100 and 200, and then there's 9 and 0. Right, you're only doing the first one. Okay, I'm sorry, guys. So, Corio says, yeah, 2 runs forever, but 1 is 1 second, the other is computer's speed. Yeah. Not weakness, lack of familiarity, exactly, Templar, thank you. But yeah, you definitely need threads for sure. Can I make that work real quick? I haven't used threads in a minute. Let's see if I can do that real quick. Again, I'm sorry, Corio, and I'm sorry if you're always here for Pokemon. I'm trying to answer as many questions as I can, but we're getting a little bit sidetracked. Let's go down to threading. All right, you probably just want to use threading. It's real basic. Let's just get 2 loops going at once. I can do that real quick. I can't nest them for you. I don't really have time, Corio, but we'll get 2 threads running so you can get a feel for how that works. Import threading. Right. We're going to have 2 loops going. We'll say function A is looping. We'll say function B is looping. We'll have them both loop. Time.sleep, 0.5 seconds in this case. And we'll say, function B is looping. Right, so we have 2 loops, right? Then they both can't run in the same thread. They're both while true loops. They can't both run, right? But you can have more than one thread, though. So you can define a thread using threading. We'll just say, thread A equals threading.thread, and it doesn't need a group. It just needs a target, right? So target equals function A. Isn't that how that works? I haven't done this in so long. I apologize. And then thread B equals threading.thread, target equals function B. And then you can just say thread A dot start, or is it run? And then thread B dot start. Let's see if that works. Yeah, see? So they're both running now. Right, they're both looping. As you can see, because B is only a 0.5 seconds, it loops twice for every A. You get 2 B's for every A because B is twice as fast. Right. So basically, what's kind of hard to understand, perhaps, is that all this code here is what's called the main thread, right? So this code runs in the main thread of execution. All this stuff, like this thing here, where you're reading straight down here, that's all the main thread. It goes straight down from top to bottom. But then you make some threads, and they can run in their own little programs, basically. They run separately. Threads are not loops, no carbon. Basically, threads, let's talk about threads real quick. Threads are a way to have your code run multiple instructions at the same exact time. For all of our examples previously and going into the near future, because this is kind of an advanced idea. We're not going to talk about this in the future, guys. We're going to have to come back to this probably weeks from now. But we're kind of helping my friend Corio right now. But for all of our examples previously and going into the near future, code is read from top to bottom. And when one function is running, you can't also be running other functions at literally the exact same time. There are many use cases in the real world where you'll want to have multiple pieces of code running at once, as if you had, opened up multiple browser windows, or multiple video games at once. Right? You can have two things running at once, basically, right? And Python and in computer programming, you do this using threads, which just means, let's just say using threads. A thread is an independent course, right, for instructions to be run on. So you can have more than one thing running at once using threads. Nickel count equals 100, dime count equals 200, total coins equals 0. Total coins equals nickel count plus dime count. Print total coins. Exactly, Code Moo. Yeah, that's exactly what you need. Yeah, you can do that too, Corio. Yeah, you can just do it directly if you want. You won't be able to kill your thread later that way, though. So if you record your thread, like give it a name, you can kill it later, or some other kind. You can get data from it later in a more easy fashion. But you can just run it directly if you want. You can just have it be like, like you said, like this. If that would please you. Then you don't have a reference to that thread anymore. You can't mess with that thread. It's just running wild, like WrestleMania. You can do that too if it would please you. Templar says, threads execute a command. One example of a command is to execute a loop. Yeah. Basically, if you only have one thread, which is the default, and you're looping over something, as you'd expect, you're stuck in that loop. That's all you can do is do that loop, right? But if you have more than one thread, you can have one thread do that loop, and then one thread doing something else. Exactly, Carbon. Let your code multitask. That's exactly what it does. Let your code multitask. If I assume correctly, threading is being able to run loops that would block your program if not used. Exactly. Like SQL queries, you can either run it or get the result in a variable. Yeah, in Python. You probably want to have a reference to the thread, or maybe not. But so basically, threading is for multitasking. And for our purposes as beginners, we're total beginners here. We have no use for threading right now. It sounds like Corio is trying to get in some deep shit for his class or whatever, which is cool. I appreciate that. But yeah, for our purposes, threads are not really needed. Later on, as our tasks become much more complex, we might need to use more than one thread of execution to get what we want. For now, though, we're quite happy just doing one thread and doing all of our code in a straight line. That makes it a lot simpler for beginners as well to understand. Okay, guys. Boy, that's kind of fun to talk about, actually. Oh, I closed idle. Wow, I'm a dum-dum. How'd that happen? I'm a dum-dum-dum-dum. Dum-be-dooby-dum-dum-dum-dum. Here we go. Let's reopen this. I wish I could help. Corio, if you want to join us on Discord, that's at vencabot.com, or look below my stream. There's a big button down there you can click. We have an Intro to Python section where we can talk about this in more depth when I'm not actually programming live. If you have problems, I can help you out at a more fine level on Discord later on. If it would please, I'm not sure what your deadline is on this. I can't really probably help you until the end of the stream at the very earliest, which will be around in the late evening. Thanks for the follow, Corio. But yeah, if you want to talk, any of you guys in the chat want to talk about questions you have about Python or programming in general, and you don't need the answer like instantaneously, join us on Discord. We can talk about it there anytime you want. That way I can look at your code and we can discuss more than one option. I could help my friend Corio more with understanding how threads work with more examples. But yeah, right now let's try and get back onto our simple game dev example. Let's get to F5 going, y'all. Let me shrink this and put it on the screen the way it was before. If you guys here that are total beginners, do not worry about threads. It's something we're going to come to later. And once we learn threads, it's going to be so great, guys. Threading is great. Don't get me wrong. It's really awesome. But this is really more of a course designed for people that have never programmed in their lives before. And they're really trying to look at the very basics of programming. And threading is a little more advanced. Thank you, Hello Code Blue, for the follow, man. We play, we're more like a gameplay channel. We stream games for 40 hours a week. Except on Fridays, where we stream a little bit of Python on Fridays. Got some Node.js looking at pip modules from people. Is that bad to use? Nothing's bad to use, Corey. There are no, there is no good or evil in Python. It's just that I personally feel, Corey, and for all you guys, that it's really best to learn starting at the ground level and then working your way up to... You probably want to write most of your own code. As you use more advanced libraries, you're kind of relying on third parties to solve your problems for you. And that can make things more confusing in the long term. It's probably best to figure out how the code works before you start using other people's solutions to problems. But that's just my personal opinion, Corey. There's nothing wrong with importing any library and using it to its potential. That's the whole point of the pip system. But in our case, we kind of been avoiding libraries, if you may have noticed that, right? You guys have been following me since the beginning here. You have noticed we've been avoiding using libraries, more talking about how to define your own classes, how to define your own functions, how to define your own variables, and how to use them in expressions, that kind of thing. We're looking more at the creative side of Python and how to understand how code looks and how it functions. And then after that, we're going to look more at importing libraries and using more advanced code. Yeah, applesauce. Dude, I'm so sad. I went to Yumacon, I lost a big bag of apples. I couldn't. Our hands were so full with luggage, I couldn't carry it out of the hotel room. So hopefully those maids enjoyed it. They probably threw it away, man. That sucks. Anyway, I'm sorry, guys. So here's where we are in our code right now. Now we define these two Pokemon, right? Pokemon 1 and 2 from our Pokemon class, and we're feeding in a list that has a couple of classes in it that represent Pokemon moves, right? It has a tackle, and it has a comb hair. Right? And so then this code runs here. Over using this list we made. Let's actually highlight the dict as well. Move dict. Okay, let's go back to our notepad example. Gotta scroll this a little bit like that. Okay. Let's go back to talking about how this these three lines work. Dicts, my hands were full, so I left behind a bag of apples, yes, as well as a more or less complete bunch of bananas. Now, you have to understand, Dix, that my hotel was it's like a 20-minute walk to my car, where I parked my parking lot. Yeah, Dix, you don't understand, Dix, all right? My car was like a 20-minute walk from my hotel room, because we were parked downtown in Detroit. We couldn't really park where we wanted to park. It was super busy. There was no parking spaces. So when I was moving my cot, I moved my little bed, and all my blankets and my pillows and my clothing, I had to haul that shit down the street. I took 2 trips, man. I didn't want to take 3 trips. Exactly, Wade. Fuck the apples. I mean, I was sad. I love apples. I love apples, guys, but I couldn't take another trip. It was just too much. Okay, so let's talk about these 3 lines of code here. Thank you, Faust. A moment of silence, please. So, in our example, let's say in our Pokemon example, the last bit of data that we feed the Pokemon's instantiation is a list of classes. These classes, Deep Swag, don't blame me, Deep Swag. All right, blame the maids who probably threw it away. I hope they enjoyed it, man. Those are some good apples and some good bananas. But I imagine it's probably against their protocol to eat food they find in the rooms. I imagine that's probably not a good idea most of the time. These classes represent a Pokemon's moves. In our case, we're feeding in 2 different moves in that list. Tackle and comb hair. Right, as you can see here, we have two classes. One's for tackles, and one's for comb hair. Although all tackles are the same in practice, right? In actual, in the game Pokemon, when you have two Pokemon that have the move tackle, it works the same way, right? It works the same way, no matter which one's using it. We instantiate tackle because behind the scenes, it has some attributes that are unique, right? Because there are unique attributes per tackle, we can't just reference the template, we'll call it, or class, of Pokemon move tackle when we want to talk about a tackle in particular. For instance, an instance of tackle records how much PP or ammo that tackle still has left, right? So basically, if we just used this class to talk about tackle, then we wouldn't know how much PP Bulbasaur's tackle has versus Squirtle's tackle versus Pikachu's tackle, right? They all have some things that are unique about them, right? Yeah, sure, tackle works the same for every Pokemon, but every tackle has a unique amount of remaining PP. So for that reason, we don't just refer to tackle as the idea of tackle. We're talking about a tackle in particular, a tackle that has 7 PP left, or a tackle that has 10 PP left. And in this case, it has some other unique things too. It also has a unique owner. Right, let's talk about that. So let's go down here and highlight our code again. This is the code in question we're talking about, these 4 lines. Surprisingly complex for being 4 lines. Let's shrink this a little bit. Okay. Another thing that an instance of tackle has is an owner, right? So by having an owner attached to it, our tackle, or any move for that matter, can reference all of the attributes of the Pokemon that's using it. For instance, tackle needs to know how much attack power its owner has so that it can calculate damage. Right? See what I mean there? So basically, although all tackles behave the same, we could just say, instead of having an instantiation of tackle, just have a template and just talk about the template, right? The template has all we need to know about it. But that's not the case, right? Some tackles, they're made equal, but over time, they're gonna have to have unique qualities, how much PP they have, who's using the tackle, right? That kind of thing. So for that reason, we're instantiating all of our moves. So, for that reason, we're instantiating all of our moves from a class which represents that move. I love talking about PPs, dude. You know me, dicks. Okay. So, we've defined 2 classes representing 2 different types of moves. We've got tackles, and we've got comb hairs. In our example, both of our Pokemon are given both of those move classes in a list. Right, that list is right here. Right, so they're given both these different classes. But we're talking about the class itself, not an instance of that class. We're talking about the actual class. Although we feed our Pokemon a list of move classes, the Pokemon doesn't actually save that list. Instead, it saves a dictionary of move instances, right? it gets a list of classes, and it saves a dictionary of instances. So we basically have to convert. We're going to convert this list of classes into a dictionary of instances. That's what we're doing. We're kind of converting it across. An OS2 player, huh, Corey? So it's like a rhythm game, right? I think it's PowerPoints, yeah. It's like an ammo. It's like an ammo count, basically. Every time you use a move, it uses up its ammo, which is PP. The Microsoft PowerPoint. Okay, so we have a for loop which uses that list of classes to create a dictionary of instances. So Starkey says, I'm a noob on this starting learning Python a few months ago. Nice, man. A Raspberry Pi, sick, dude. That's a really cool way to learn Python, because that's have a little machine there to do your job for you. It's got all kinds of cool mechanical outputs. That could be a lot of fun, homeboy. Any questions, Starkey, that I can help you with right off the bat? Boy, your handle is really crazy, my dude. I'm not going to read that on stream, but yeah, there's a repo. I'll put it in the chat for you. Yeah. If you want to read our previous examples, which are fully commentated, previous examples from Intro to Python, which are fully commentated, go check out the repository at github.com/Vencabot/Intro to Python. You can also watch the previous streams that those examples came from at youtube.com/Vencabot archive. Okay, guys. So, what do we got here? Okay, with this for loop, but these really complex 4 lines, right? There are 4 lines, we've got a little loop here. What this loop is doing is it's taking this list of classes, and, you know, this for loop is taking this list of classes. And for every class in that list, it's making an instance. It's then saving that instance to a dictionary using that instance's move name as the key. Thanks for the follow, dude. This is Rex TV. Starkey says, indeed, so I'm learning the TK module that's built in already, but it says I can't find the module when trying to make a basic box. Well, Starkey, can you give me the error message exactly? What's the error message? Can you put it in the chat? When you try and run this code, you get an error message, right? Corio says, what I find cool about Python is that it forces people to use good tabs. That's what I love about it, dude. Making it impossible for example, JavaScript, making random tabs. What Corio means is that in Python, white space is significant. In most languages, you can actually have any amount of indenting. It doesn't really matter. And for that reason, a lot of programs use different amounts of indenting, which can make it hard to read. In Python, it enforces a certain amount of indenting, which I think makes it more uniform and a lot easier to understand. I love Python for that reason, especially. Been lurking a little while and continue to lurk. I like lurking in streams while I code. Good stuff, Rex. Hope on board, dude. We play all kinds of cool video games here. Retro games and modern games, horror games and shooting games, all kinds of crazy shit. But on Fridays we program. Don't get discouraged, guys. You come by on Monday and I'm playing, like, you know, Mega Man Legends, or I'm playing Street Fighter 3. On Fridays we always program. A little bit cleaner, Corio, you're right. Now take your time, Starkey. Okay, so I think that now, I'm not sure if my friend Carbonite is still around, but in any case, I hope that we can understand a little bit more what this for loop's purpose is, right? It takes a list of templates or classes, and it uses each of those molds to make a move, and then it puts that move in a dictionary, right, for later use. Good stuff, Carbonite. So we have this little for loop. It takes a class out of this list of classes, and it makes an instance of that class, so it makes a new move out of that mold, and then it assigns that move into a dictionary using its key as a name. So in this case, we're making a tackle. It's called tackle, right? So we're using it at move dict. We're assigning it the key of tackle. Then we're assigning the move to that spot, into that slot in the dictionary. So what we get is a dictionary that's got a tackle, right? So we can say, you know, like, let's just go back here to Notepad. So our result is that our Pokemon's move dict has 2 entries. And they are, you know, like let's say Pokemon 1, right? He has Pokemon, he has a move dict, he's got tackle, and he's got comb hair, right? Because the key we used is the move name attribute of the move we just made, right? As you can see here, they both have a move name. Here's the move name right here. Tackle is called tackle, and comb hair is called comb hair. So we're using that as a key for our dictionary. I highlight this again here. All right, so we have these moves now, right? We can access these moves by their names. Kind of convenient, right? We access the move by its name using this dictionary here. That's why it's better than a list, right? Because we can actually get it by name. And then when we access those moves, we can access those moves methods, right? So all we're doing right here is the most complex line, I feel like, in our code. You know, we have this 4 lines here, and the result is this complex line right here, right? Pokemon.moveDict tackle.useOn Pokemon 2, right? So, you know, in our final line, which is Pokemon 1.moveDict, the key is tackle for that dictionary, useOn Pokemon 2. What we're saying is, you know, get the move at our Pokemon's tackle key, or our Pokemon's dictionary's tackle key, and run its method, useOn, with the argument Pokemon 2. In fact, here's what I can do. I can actually break that line up, make it a little bit simpler for you guys. Let's break that line up. Let's break that line up. Fuck it. So let's take this line of code and just change some things around. Let's just say, you know, we're going to call, you know, the tackle in question, right? We're going to get tackle out, right? How are we going to get this tackle? We're going to get Pokemon 1.moveDict tackle, right? So this is getting a tackle out of this dictionary, right? We're assigning it a name, tackle in question, right? Now we can use that tackle. Tackle in question dot useOn Pokemon 2. Right. So we're using this tackle, and it has a method, right? Which is useOn. All tackles have this method. All tackles have a method called useOn, and it takes one argument, which is tackle, target. Right. The self is implied. It's a method. Think for the follow argsam. We program here on Fridays. We're saying, get the tackle out of the dictionary. We made a tackle right here, right? This is where the tackle got made, right here. And here's where we got assigned to the dictionary, right? Got assigned by its name, tackle, to this dictionary. Now we're getting it out of the dictionary. Pokemon 1.moveDict tackle, right? We're going to call that tackle in question. And now we're going to use it. Right? We're going to use this method of it on Pokemon 2. That makes the tackle actually execute. Right, let's look at our code. Let's actually run this. Okay. So we ran tackle, right? And what happens when we run tackle? We get a little cute little message here. Cyndaquil tackled Squirtle. Squirtle took 4 damage. Squirtle has 64 HP remaining, and tackle has 9 PP remaining. That all happens when you tackle somebody. No mod named T. Kinter. Okay, let's figure out why that might be. Let's go here to our library reference. I think it's called TK, not T. Kinter, right? No, it's called T. Kinter. No module named T. Kinter. Import error. It sounds like you're not using for real Python, my homeboy. Because it should definitely have T. Kinter. Maybe you're using like a slimmed down version of Python that doesn't include all the libraries. Because I should be able to import T. Kinter. No problemo. Let's do that real quick. Let's just run CMD, for instance. Right. And let's just literally just run Python. And I can say import T. Kinter. Boom. Imports. No problem. I feel like maybe you're not using vanilla Python, Starkey. Because it should have T. Kinter built in, like you said. You shouldn't have to download anything for T. Kinter. I mean, you could try and download it. You could try pip, pip T. Kinter to download it and install it. But that seems weird to me that you have an import error for T. Kinter. I mean, if I tried to import, Blooty Blue, I have no Blooty Blue, right? Module not found error. No module named Blooty Blue. So it's not called an import error either. That's weird. For you, it's called import error. This is a module not found error. No module named Blooty Blue. Yeah, I feel like maybe you're not using Python. They're using some kind of spin-off of Python. Okay. So, going back to this example, right? This example we have here of this Pokemon move. What we're doing is, all that crazy complex line was, it was just a combination of two lines. You can break it up as many lines as you want, really. I see there is a 2.0 and 3.5 Python. Yeah. Does 2.0 not have tkinter in it? You probably want to use 3.5 though, Starkey. That's the most modern version. In my case, I'm using 3.7, I think, right? Or is it maybe it's 3.5? I don't know. Let's go check. What is the most recent version of Python? Where are we at? 3.7, yeah, 3.7.1 in fact. Maybe you want to uninstall Python, Starkey, and reinstall it. A little more up-to-date version. Okay, so in this case, we split up our line into two different lines, right? By using assignment. So we can just call this like rtackle, right? Rtackle. We're fetching it from this dictionary, and then we can use that tackle. Give them both, huh? Well, I'm not sure how it should. Have you tried using the py command, Starkey? Like, I think Python is distributed with a py command, which automatically should use Python 3, if I'm not mistaken. Let's use CMD here, because I can run Python as well, right? And maybe that's what you were doing. Maybe you were actually running Python 2 explicitly, like with Python 2. I think that's a command, maybe. But if you run py, it picks the version for you, and it should always use the most up-to-date version, I believe. So if it has 2.0 and 3.5, try running py and see if it runs the 3.5 version. Okay, so let's go back to simplifying this line. Now this line here, it's visually easier to read now. It says rtackle is a Pokemon move 1.moveDict tackle. Then we're saying rtackle.useOn, right? Two different lines. But that was easier to understand as a beginner. You can actually simplify this by putting it onto one line. So we're saying, get this tackle out of here, out of this dictionary, access that tackle in the dictionary, and then use it. All right. So one more time, what we're doing here is we're feeding in a list. Let's go back to our notes here. So yeah, we're taking a for loop. We're taking a list of classes and using a for loop to turn that list of classes into a dictionary of instances of those classes. Right? So we're feeding in some move templates, and we're using this little for loop as like a little factory to use those templates, use those molds, and make a move from each of them, and then save them to a dictionary for that Pokemon. Right? Based on their name, using their key, using their name as a key. Okay, so we can actually also do, Pokemon 1.moveDict comb hair use on, right? Nobody doesn't need a target, right? It does have a target, right? Does it? They don't need to use it though. Let's use on Pokemon 2. Who cares? So we run this code now. Okay, so we have the tackle happens, and then he also combs his hair. Right, so it combs its hair. Hey, thank you, Kenny. That's exactly what the problem was. Thank you, Kenny, for that bit of info. So they changed the name of tkinter. That's why you're having that import error, Starkey. They probably also changed import error to module not found error. Ugh. So finally, I think we're all caught up with the code we wrote last week, just in time to end the stream here. Mostly spent this whole stream reviewing, right? But that's cool, though. It's important to review and learn stuff. Instead of adding a bunch of new code today, why don't we wrap up by looking in greater depth at the importance of attributes. Let's go back to our notes here. In these past couple of streams, we've been looking at the importance of object-oriented programming, or saving variables directly to another object in the form of an attribute and saving functions directly to another object in the form of a method. Yeah, I think you're right, Carbonite. You're totally right. It's better to go back and look what we did before moving forward, right? We're gonna kind of figure things out before you take a step forward. One of the coolest things about attributes is that they're, they can be changed. They can be changed and resaved. Now let's look at how we're using that in our existing code. So here in our tackle code, right, we have this useOn function, right? It takes a target. Now we know that tackle already has an owner. We know who's using the move. That's the owner. And the target is where we're tackling. Right? So what we can do is we can calculate damage here. I figure how much damage we're doing based on the owner's attack power, like self.owner.attack. So because the owner is a Pokemon, we know it has an attack, right? It's one of its methods, one of its attributes right here. Every Pokemon object has an attack attribute. So we can say, actual damage is self.owner. That's our owner's attack, right? I mean, the dots are apostrophe S's in English. They're possessive. So our owner's attack minus our target's defense. That's our damage. So if our owner's attack is 4 and our target's defense is 3, then our damage is 1. Right? So what's kind of cool about this is that in our first day of programming, our first, actually a couple days of programming, we didn't have classes yet. We had only loose variables. And we had to feed them all in as arguments. There was a ton of arguments here, right? So it was like, an argument here. It was an argument there. There's another fucking argument. It was just a ton of arguments, right? But they all were meant to express one idea, which was we have our Pokemon A, and we got Pokemon B, right? So why we got to feed in like 20 arguments just to say Pokemon A and Pokemon B? Instead, now we are grouping those variables as attributes to an object. It makes it so much simpler to understand, right? We just have an owner Pokemon, and we have a target Pokemon. And yeah, they've got attributes, but we don't need to type them in every time. We don't have to type in every single attribute every time. Just type in the actual Pokemon itself. And we can access that data. We can access its attack power, right? We can access its defense. We can access its type, right? That's kind of cool. So here we say, if this tackles, if this tackle in particular, self.currentP, if this tackles PP is at 0, then we can't use it, right? So return, end the function, we're done. We can't do this code down here. This code's for actually tackling the opponent. We can't do that because we're done. We have no more PP, so skip all that shit. And then if it does actually have PP, we get down to this point, right? And then we say, we print off a message saying the owner's monster type, so Bulbasaur or Cyndaquil, that's the owner's monster type, tackled the target's monster type. So Bulbasaur tackled Cyndaquil. Right? This code here is just to add a little message for the user to read. Then we calculate damage using the owner's attack power and the opponent's defense. Then we make sure that damage is a positive number. If let's say that our attack power is like 3 and the target's defense is 4, that means that now we're doing -1 damage, which will heal the opponent, right? -1 damage will heal the opponent. So we're going to make sure that's a positive number. We say if actual damage is less than 0, right? If it's less than 0, then just assign it to 0, right? Don't go below 0. If you're below 0, just make it 0. How do you feel about Arksum? I'm trying my damnedest here. I know I'm talking kind of fast for you guys, but that's kind of how I learn. I kind of like to lecture and learn from lectures. So I apologize if I'm talking fast, guys. I always talk fast anyway. But here's where the true power of attributes comes in. Think for the bit, dude. The true power of attributes comes from changing them. Now, I was talking to my friend Kenny, right? My friend K. Reich Jr., about state and how changing attributes can be very dangerous in your code because it can cause unexpected bugs down the road. But there are programmers out there who are called functional programmers, and they totally do not like to use instances or classes or anything that's object-oriented, because when you add these this level of complexity to your code, it really does encourage bugs to pop up. It encourages you to overlook something, and now this thing's going to break, and you don't know why it broke because there's so many moving parts, right? Whereas with our old code, our first couple days of programming here on the stream, we used functional programming, which was no classes, no objects, just straight up and down, straight from top to bottom programming. It's very easy to understand, but it does have a trade-off. It's hard to write. It's very hard to write that kind of code. You repeat yourself a lot. You've read the same code over and over again. It's kind of hard to, if you don't have your data grouped together in a class, it can be kind of hard to think of that data, right? It's kind of like, it makes more sense to think of a Pokemon as a thing with attributes than to think of it as a bunch of loose variables, right? So there are pros and cons to using classes, and let's talk about that in a second here. The cool thing about it is we can do this code right here. Target.hp equals target.hp minus actual damage. Okay? Why is this code special? Well, because previously, let's go to another example. Let's do a new file. And we're going to save this as a functional programming example. Right? Let's save this as a functional programming example. Right? That means no objects. We talked before about, a basic function, which takes some argument and another argument, and then it returns some kind of data. Right? Let's just say, some kind of data equals some argument plus another argument. And then we can return that data. Right? So now we have this very basic function, and all it does is take two arguments and return some kind of data out of it. So we can say, our new data equals basic function, 4 and 2, and then print our new data. Right, let's just run this code now. There. So it printed off the number 6, right? Because it's just, all it does is it takes in two numbers as arguments, and then it combines them here, and then returns the new data, right? We just print off whatever got returned out of the whole thing. That's very simple to understand. You put data in, and you get data out, right? You put data in, and you get data out, right? Very easy to understand. However, as soon as you start putting classes in there, it complicates shit, right? Like, let's do an example, for instance. Let's do one right here, right? We're gonna do a class. Oh no, a class, right? We have this fucking class now. It's gonna ruin everything. Ruin our beautiful functional code. All right. Self dot, our fucking state equals 0. You put data in, you shake it all about exactly, Wade. That's what it's all about. Faust and Wade. Way ahead of me already. Okay, so now we have this fucking class, right? It's gonna ruin our beautiful functional code because it's gonna have this thing, this attribute, that can change in a way that's not as simple as putting data in and getting data out, right? It's not that simple anymore. Let's see why that would be. We're gonna feed in, some fucking class now. We have 3 arguments now, right? Or some fucking, let's call it some fucking instance, right? So we're gonna make, with this our new data, let's call this our instance, right? Our instance is going to be, it's going to be an oh no class, oh Noah class, right? There, that's what it is. It's a very simple class, and it's got this this attribute attached to it, right? This is our fucking state is 0, and we have this function here. It's going to add these two functions, add these two arguments together as it did before, but it's going to say some fucking instance dot our fucking state equals 5 or 4 or whatever. 5 is great. Okay, so we fed in some data. Let's feed in this instance as well. We fed in some data, and we got some data out, right? Let's verify that. Okay, so we still feed in some data. We get a 6 out of it, right? But what if I were to print, you know, let's print off, you know, print our instance dot our fucking state right there, and print it down here too. Print our instance dot our fucking state. Right? So let me actually put this right here. So you guys know what's going to happen, right? Let's talk about this first before we even see it. What's going to happen here is that we defined an object, our instance, and then we printed off its state, right? Its state is 0, right, guys? The state is 0. And then we ran this function. We fed data in, right? There's the data we fed in right there, the argument, and we got some data out, our new data, which is going to be, you know, it's going to be some kind of data, which is going to be the additions, the sum of the first 2 arguments. But something else happened, right? We fed data in, we got data out, but look at this shit right here. We are also changing the state of this instance. So although we put data in and got data out, there is what's called a side effect, right? Which is to say that this attribute changed. So if we print off the state before the function runs, and we print it off after the function runs, it's going to have changed, even though nothing got returned differently. All right, let's try this code now. Yeah, see, so it printed off 0, 6, and 5. So the state was 0, and then we ran that function and got 6 out of it. But not only did we get 6 out of it, but this state became 5. So that's what functional programmers hate. They don't like the idea of an object because it ruins the simplicity of putting data into something and getting it out. Because not only does that happen, but things might also change you did not expect to change. So Faust says, I wish I could change my RuneScape name to Biggest Dickus without fear of getting banned, huh? Biggest Dickus. I have a very great friend from Rome named Biggest Dickus. So this is a blessing and a curse. That's why I want to stress that to you guys that are beginners in programming, that having attributes on your objects is a big responsibility. Because this line of code right here can cause bugs like you would not believe. So the advantages of functional arcsum is that your code is going to be much less prone to bugs, because you always know, just from reading the function's arguments and reading its return value, what is going on in that function. Right, let's just kind of get rid of this line right here, for instance, right? So from reading this, you know, this argument here, this function, you know that it takes 2 pieces of data in and gets 1 piece of data out. And if I had been using some stupid names, you also know what it does. Right? You should have a good name for your functions and for your arguments that's not like this, where you know what it's used for, right? So you know that when you assign your data like this, right, let's actually do it like this. You can read this line of code right here. And you can say, okay, I'm putting in 2 arguments, 4 and 2. And I'm getting out our new data. I'm getting something out of it. But if you were to do some instant stuff like we were doing before, you don't really know for sure what's going on in here. You can see this function, right? You can see what's happening. You can see, you know, it's a name. It's got 2 arguments for sure. But you don't know what's going on in that function, man. You have no clue what's going on in there, because it could be changing all kinds of crazy shit. Right? Yeah, you're getting data out of it for sure, but what else is it changing? There's no way to know. You have to read it. You have to scroll up and read it. It's kind of frustrating. As your code gets bigger and bigger, that can become very dangerous. Arcsum, it's not really that it's hard-coded, but yeah, exactly like hard-coded. It's more repetitive, because you're writing lots of argument names, right? You're writing in lots and lots of argument names, like so many argument names, man. Like oh my god, all these arguments, right? Because if you have kind of complex functions, it can be a lot of arguments. But it's still flexible, because you're still probing the user for what goes in, right? Basically, any program is hard-coded, right? Every program is hard-coded. The user puts something in, and the program does some calculations, and then something happens on the screen, right? That's kind of how programs work. And that's no different if you're doing functional programming or object programming, right? That's always the same case. It's just that it's more rigid. I think what Arkham's saying is it is more rigid for the programmer. I have to write everything very, very explicitly. And that's exactly why functional declined in popularity in, the 80s, right? Back in the day, back when computers were still brand new, everything was always functional, right? Every language was functional back in the day. And then object-oriented programming rose up in popularity as more languages were created that supported them, right? Supported objects. And now there's a big resurgence in functional programming because a lot of us grew up with object-oriented programming. I grew up with Java and JavaScript and things like that. And all of us, object programmers, we've had these bugs, man. We suffer with these bugs that are really hard to diagnose because these functions, these methods have side effects, right? They have things that happen inside of them that are very hard to keep track of. So there's a big resurgence now of people saying, don't use objects. It just makes your code fucking harder to understand, right? Just have it be real rigid and straightforward of what it does and have it be really explicit and just don't have things being changed around behind the scenes. It just causes bugs, right? And that is true to an extent. That's true to an extent. That's why I want to warn you guys. To me, object-oriented programming is super important. It's super convenient. It's something that I wouldn't want to live without. For reasons like this one, right, in our example, right? It just makes so much more sense to think of Bulbasaur as having these attributes, right? He has these attributes about Bulbasaur, and he has these things he can do. Those are his methods, right? Yes, it's not necessary. We could do it all functionally, definitely the same as we did, in fact, right? We did it all functionally already in our previous episodes. It's just that as your code gets more complex, you're going to want to find ways to organize it so you as the programmer can understand how it works, right? I mean, once you have the code written and you're running it, it doesn't matter. No one sees that code ever again, right? Hypothetically speaking, your source code is now not an issue anymore. Your code is working fine. But as a programmer, you want to group things together and attach them to each other and make like a network of how things interact, right? And that's exactly what object-oriented programming does. But here is the great strength of it and the Achilles heel of it right here in tackle. It says target.hp equals target.hp minus actual damage. Okay, this is such a powerful line of code. It's so simple but so strong. Here's why it's strong. Because we are not only referencing his HP that he has right here, we're referencing it, but we are changing it. We are saying, bro, this Cyndaquil, he had this much health left. Now he has this much health left. And what's cool about that is that we don't got to return a value, but we don't got to return his new health. We don't got to return anything. We can just change it. We can just change it at will, change his health. And now anywhere else in the code where we ask about Cyndaquil's health, it's updated now, right? I can feed Cyndaquil to 10 different functions or methods. I can feed all this data to those methods. And now in all those methods, his health is consistent, right? It doesn't matter what function I'm running. He has 8 health now. Oh, we got another 2 taken off it. Now it's 6 health. That's true of all these functions now. And that's so easy to keep track of, right? It's so easy to understand as a programmer. It makes so much sense. But the problem with that is, again, if you do it irresponsibly, now you might try to figure out why does Bulbasaur have 12 health now? He had 20 health before. I only did 1 move. Why does he only... I should only have done, 3 damage. Why has his health got lowered by, 8? So you're looking through your code, you're trying to figure out what the fuck caused that problem. You're scrolling through thousands of lines, and you're like, oh, well, for some reason right here, his HP is being changed right there too. Okay, or this code's running twice. That code's running twice, so it's making his health get diminished twice. Okay, but it's kind of hard to understand. If we add a new Pokemon or move, we just make a new list of attributes. Exactly, right? We can just do this one line right here, and this line here where we define the Pokemon. Right. And also, I want to talk about inheritance today. I want to talk about inheritance next time, I guess. We kind of got sidetracked here. But also, this Pokemon move. We talked before about how classes act as molds for instances, right? That's totally true. You use a class, and it spits out an instance of that class. But what we did not talk about, we should do that right now, in fact. We have time. We got another 10 minutes. I can run a little bit late. But you can also use classes as molds for other classes to make things really simple and not have to rewrite the same lines of code over and over again. Right, let's do that immediately. So as you can see right now, I kind of want to set that up earlier by having these two things, Pokemon move tackle and Pokemon move comb hair. Right, now they're both called Pokemon moves, right? But in both of them, what do they have in common? Well, they both have an owner and a move name and a max PP and a current PP, and all this is the same. Right, it's all the same. So why are we writing it twice? Let's just write it once. Let's make a new class called Pokemon move. Okay, all Pokemon moves are of this class, right? Again, you can have a template can be a template for an instance or for another class. So it's Pokemon move. Okay, and let's give it an init. Right, it's got self. It's got an owner. Right, that's what they have in common. Right, tackle and comb hair both have two arguments in their init, self and owner. So let's have them. They have self and owner. They all assign owner to themselves first of all, right? And then they all have a move name. Well, let's do it like this. So they all have a move name, right? But that move name will differ. So let's just have another argument here, right? Let's give it a move name. Okay. And then they all have a max PP. All right. But how do you define that max PP? Well, let's give it another argument, max PP. And they all have a current PP, which starts off at its max PP, right? There you go. Right, these moves have that in common, right? It's tackle and comb hair. And then they have a type, right? That's going to be, another argument. Elemental type. Now, let's say all moves also have a use on method. Right, and they all take the same thing, self and a target. By default, what should it do? I mean, nothing, right? This is a very generic move. It doesn't have any features yet of its own. It's just this idea of a Pokemon move. So let's just say, print. By default, it just says, self.owner dot monster type plus used plus self.move name plus this actually makes it a little bit longer. I'm sorry. I have to go a little bit further down here. I don't want to go off the screen. 1, 2, 3, 4. Move name plus on plus self.target.monster type plus exclamation mark. Right. Okay, so by default, use on, all it does is print off a message saying, the owner used the move name on the target. That's all that it does by default. Let's talk about how this works now. I'm sorry, Johnny, I can't argue with the computer. You're right. Why even bother? It's going to take over the world anyway before too long. Okay, so how does this change how we define tackle and how we define comb hair? Well, now we can just call this tackle for one thing. We can say tackle inherits from Pokemon move. Okay, this is a new kind of notation for us here. Right. So basically, when you define a class, you can define its name like this, class Pokemon move comb hair. But you can also put in parentheses another class that it's based off of. It has all the things this class has. Right. That's kind of cool. Right. So, in fact, why don't we add a new method? Let's call it def dot initialization. How about we say print startup, right? And it's going to be this message here. In fact, let's just overwrite this. Let's change this to be like def use on. So by default, use on is going to just use this other method, self.print startup on target. Right, it's going to be print startup now. Okay, so now every Pokemon move, that's game code, Lord Johnny. Every Pokemon move has 3 methods. It has init. It has print startup, which prints a message about the move starting up. And default just says, you know, so-and-so used some move on so-and-so. And then it has a use on method. And by default, that method only has print startup as a part of it. Right? Okay. So now we have tackle, and it inherits. It inherits from Pokemon move. So what does that mean exactly? Well, here's what it means. It means that we have access to a new function we have not learned about yet, guys. It's called super. And what super does is in any method you run it inside of, it will run that same method on the parent class. So when I say super inside of init, I'm actually saying use my parent's init. So we're going to say super, I think that's how this works, right? Or am I wrong about that? Maybe super refers to the actual object. Let's try this. Let me actually review how super works before I talk a bunch of shit. Go to the library reference, go to the built-in functions, and we should have super here. Super. There it is. Welcome aboard, Brazil. That's Portuguese, right? I wish I could speak Portuguese for you. Okay. Okay, so it refers to, super refers to the parent class, not to the parent method. I'll show you what I mean by that. Okay, so we have this super, right? That refers to Pokemon moves. So we're going to say super.init. We're going to call our supers init. We're going to say give it an owner, but also give it the move name tackle, give it max PP of 10, and give it elemental type normal. So now we have taken all these lines of code right here and simplified them away. Boom. They're gone. So much more simple now. So what we're saying now is that we're saying make a new move based on Pokemon move. It's called tackle. And when we run init for tackle, just run the init from the parent and give it these arguments. Right? Give it the owner we got, the same owner we got in our tackle, but also give it the move name of tackle and max PP of 10 and elemental type of normal. Right? Thank you for the follow, Kenshiro. Kenshiro! Also, Son Hador, our friend from Brazil. Ember. To be totally honest with you, I'm not totally familiar with multiple inheritance. I've never practiced that extensively. I couldn't really tell you off the top of my head. But I know that is one complication of it, is that it makes super work weird. When you read about on Stack Overflow about people having problems with multiple inheritance, they're like, why is super not working? Why is super behaving in a weird way? So I really couldn't tell you, Ember. I'm sorry. Yeah, multiple inheritance adds a lot of complexity. It definitely does. Yeah, one thing it does is it makes super work weird. I'm not sure exactly how it makes it work weird. I know it makes it work weird. It still works, I guess, to some extent, but it behaves in a bizarre way, which is why I try and avoid it when I can. Okay, so we have this. It makes initialization a lot easier, right? The instancing, because now we can actually instance these both the same way, right? We can actually change comb hair as well. Just make this say comb hair is going to inherit from Pokemon move. And we're going to say super.init owner, and then comb hair is the name of it, and the max PP is 1, and the type is normal. Right. Once again, we can give it all these lines of code because our parent class already has all that stuff. It makes it a lot simpler. So cool, kind of cool handle there, Ember.js EQ, already a JavaScript programmer, but you're kind of trying to branch into Python a little bit. Okay, so now we have both these moves, and their init is very simple now, because all it does is it uses the parent's init. Right, so when we call this super init, we're saying, here's these arguments you need, right? You need the owner we were fed, but you also need some stuff just for us, like comb hair is the name of the move, PP and the type. And then this code up here runs, and it assigns all these attributes to us, right? So it's kind of cool. Okay. But one thing we can also do is we can now neglect to add in a print startup statement because it belongs to our parent, right? That means that we already have it. Just by having this little thing here, these parentheses and then the parent class name, we already get print startup. Let's see how that works now. So I'm actually going to comment out this code. I don't want to run this code anymore. We kind of broke it a little bit just now as we change things around. I'm going to fix that in a second though, of course. Well, it's not really that broken. Let's just fix it right now, in fact. So what we're fixing is we're changing Pokemon move tackle just being tackle, right? Because now we changed the name of the class. And comb hair is just called comb hair now. In fact, probably fit on one line, to be honest. Make it a little bit less indented and such. There you go. Likewise, do the same thing here. Change the name of the classes around. Okay. There we go. So this code should still work. Let's make sure it still works. Maybe I broke something, huh? Let's see here. Whenever you change a lot of code around, you get some typos. It still works. Okay. So what's really cool now is that not only does, let's say like, you know, our tackle is Pokemon 1.move dict, you know, tackle, right? Get rid of comb hair altogether. Then we're going to say, you know, our tackle.use on Pokemon 2. That should still work. Let's make sure this works here. Okay, so we can get the tackle out of this Pokemon's dictionary, right? Got the tackle out of there, right here. It's our tackle. Then we used it. But how about this, guys? We can say our tackle dot print startup Pokemon 2. Watch this shit. F5. Oh, I still fucked it up. Let me fix that. Tackle attribute target. I need to fix the code here. There we go. So type used on self.target. I don't want self. I want just regular target. That's my typo right there. I'm sorry. Okay, let's run this code here. I mistyped one of the names of the attributes. Okay, so it says here, sure, we actually used tackle right here, right? We used that use on function. But we also say Cyndaquil used tackle on Squirtle. Now, where does that code come from? It comes from the parent class, this print startup function. It's a method, right? Print startup. Even though in tackle, we didn't define that class. We didn't define that method. We only defined two methods, init and use on. But because it inherits from Pokemon Move, it has all the same methods that Pokemon Move has. So we didn't define it. We didn't have to define it. It's already defined up here. So same thing with comb hair. We can do that too. Let's do that right now, in fact. We can say, you know, Pokemon 1.move dict, get comb hair out of there, dot print startup Pokemon 2. Right. There you go. Cyndaquil used comb hair on Squirtle, right? So even though comb hair and tackle don't even have a print startup method per se, not defined here anyway, because they inherit from Pokemon Move, they automatically get it. So imagine how much code that can save you, right? By having all these different classes that are kind of similar to each other, like how tackle is very similar to comb hair, right? They have a lot of same stuff. They're both Pokemon moves. Because they're so similar, they can actually inherit the code from Pokemon Move. And not only is that good for giving us access to, you know, a shared group of methods like print startup, but also we can use super, right? We can actually use super now to access the parent's version of that same code, right? So even though we are what's called overriding init, we're making our own version of init, right? We're not overriding print startup. We're just using our parent's version of that, but we're overriding init, right? Because we're making our own version of init. And we're overriding use on. We have our own version of use on. But even though we're overriding them, we can still access our parent's version of them by using super. Right? We can say, hey, super.init, run that while we're going to make our own init, but also run our parent's init as well. Super.init. Right? And even though we're making our own use on, we can still use our parent's version of that by using super.useOn, right? That's also, if we want to override, a print startup, we could do that same thing. We access the parent version by using super if we wanted to, or we could just overwrite it, right? Whatever makes us happy. So this idea of inheritance is a big part of object-oriented programming. It helps us save even more lines of code by having this thing called a Pokemon move. It's conceptually a Pokemon move, right? It has all the things you need for a Pokemon move. But then you can also use that class and make other classes that are based on it, right? Such as Tackle, it is a Pokemon move. Such as Comb Hair, it is a Pokemon move. It has all these things in common with other Pokemon moves, but it has some things about it that are unique to it being, Comb Hair or it being Tackle. So we just actually saved a lot of lines just now by doing that. Kind of fucking sick, right? So we'll go more in depth about that next time. We'll do some more inheritance and stuff like that. I think what we'll do next time, in fact, is that instead of having us have a individual Pokemon whose name is Cyndaquil, what we can do is we can do like, class Cyndaquil, and it can actually inherit from Pokemon, right? So we can actually have this template for a Cyndaquil, and we can have a bunch of different Cyndaquils that are, different moves on them or different stats on them, but they're all based on Pokemon, right? We could have that next time. So as you guys can see, it's kind of like what Carbanoid said earlier in the chat, which is that what's really cool about object-oriented programming is that you can very easily manufacture lots of things that are otherwise very similar, right? Whereas in functional programming, it's kind of a pain in the ass to do that. But for something like Pokemon, where you have like 150 Pokemon, it's very useful to be able to say, hey, listen, all Pokemon have these qualities, and all Bulbasaurs are Pokemon, but they also have these qualities, right? And then there are a bunch of different Bulbasaurs out there, right? So there's a bunch of instances of Bulbasaur. There are more than one Bulbasaur in the world, but they're all of this Bulbasaur class, and that Bulbasaur class is a Pokemon, so it inherits from the Pokemon class, right? These are all things they have in common. Helps you kind of lump ideas together and very quickly create and manipulate lots of data. But guys, this is the end of Intro to Python for today. Again, we're a gameplay stream here. We play a lot of video games on this channel, but on Fridays we do a lot of programming as well. Come back next Friday for even more programming. We're going to come back to the same example and make it actually work. So in previous streams, we actually had a functional version that was fully working. You had two Pokemon, they would duke it out until one of them fainted. Next time, we're going to do that same thing for this new object-oriented code. We're going to have these Pokemon we're making fight each other and actually have some action for you guys. But as usual, guys, if you enjoy hanging out here, you want to keep the channel on, check my Patreon page, patreon.com/Vencabot, guys. I stream for 40 hours a week every week, and when the stream ends, we're going to stream all night long. It's a lot of work, but thanks to your guys' help, I can afford groceries and gas and stuff. It's very helpful. Also, you can subscribe on Twitch if you're not already subscribed here, and that's also very helpful. If you're like me, you enjoy the channel a lot, but you're not exactly rolling in dough, right? You're not exactly super wealthy. Help for free in that case, right? Get in the chat, come say hi. In fact, that's the best way to help out. Thank you, Wade. Thank you, Arcsum and Carbanoid and all you guys for making the stream more fun for me and for each other. Also, you can follow on Twitch for free if you're not already following. Tell your friends we're here, spread the word, and save clips of like funny stuff and scary stuff. It's really more for gameplay stuff. Not really for Python, but clips are still cool. The clips go on my break screen. They're good for sharing and getting the word out about the channel. Nice to meet you, Samhador. Let's create a group on WhatsApp to clear the doubts. We're on Discord, actually. The Discord's at vencabot.com. Guys, you guys are welcome to join that. Just go to vencabot.com. You'll find the Discord invite there. And we have an Intro to Python channel on Discord where we talk about Python all the time. Come by and ask questions if you like. I check the Discord multiple times per day. If you have questions, I'll answer them there, even if I'm not programming. But it's kind of cool. I'm also on YouTube, guys, at youtube.com/Vencabot archive. I have all of my past streams archived there, including all of my past Intro to Python streams, guys. You can go watch my first episode of Intro to Python and my second one and third one and fourth one. Those are where we do more functional type stuff and more basic type stuff. All available for you right now. Also, we have our repository for our previous code examples, fully commentated, much more commentated than this is. That's at github.com/Vencabot/intro to Python. That's with underscores. I'll type it in the chat for you guys. One more time, as the song goes. If you guys want to watch some more beginner-friendly episodes of Intro to Python, they're available at youtube.com/Vencabot archive. All of the code from all of the episodes is fully commentated at github.com/Vencabot/intro to Python. We also have lots of gameplay on YouTube, guys. We're more of a gameplay channel than a programming channel. We can go watch like retro games or modern games, AAA games, indie games, multiplayer and single player games. Good stuff, Starkey. Good stuff, Faust. I will see you guys very shortly with some Mario Tennis on Switch. Until then, have a nice night. We stream for 8 hours a day, guys. We're just getting started here tonight. We're wrapping up Python for now and moving on to some gameplay. It's going to be some Mario Tennis. If you guys want to hang out for that, definitely feel free. If not, I totally understand. No, wait, no. We only play 3S here on Monday through Thursday. On Friday, it's that time for sweet, sweet special events. The event in this case is going to be some Mario Tennis. Look forward to Monday, though, for some more 3S. That's for damn sure. This game's jokes are somewhat loud. Had some network problems here, it seems. Apologize because they're dropping frames.
Lord! Yo, it
I
keeps
see some
happening.
OBS that we're kind of having some network problems here at my place.
Lord! Yo, making my life easy. Wow. Yo. I like it, dude. I love it.
But we covered a lot of ground today. I mean, we didn't really get a whole lot of new code in our example, but we really went back and reviewed very extensively. I think it was necessary. We got a lot done, I'll tell you what. Doesn't quite get what we want to say with the Aegis. Well, thank you, Hador. I appreciate that, man.
Oh no! Whoa, I've never seen that before! Liquid Ted, that was a sick unblockable. Jumps out of the Gygus! No more meter for Hugo.
Got that Brazilian subscriber.
Oh my god, that's one for Liquid Ted. I have never seen that unblockable before.
Python programming in Brazil.